ஆமா. ஆமா.
உங்க கொடுத்தானா சபதத்தை நிறைவேற்றினானா?
2 மாசத்துல நிறைவேற்றிட்டான் பாரு. 2
காட்டுங்க
மாசத்துல.
காட்டுங்க. கொடுத்துட்டான். உங்களுக்கு சந்தோஷமா?
அப்ப 2 மாசம் வாடகை கொடுத்துக்கிறான்.
ஓ அப்படியா? உங்களுக்கு இப்ப ஹாப்பியா?
முடிச்சிட்டான்.
ஹாப்பியா?
ஹாப்பி.
ஹாப்பி. சரி. ஓகே ஓகே. என்ன 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 பண்ற? what you do? என்ன பண்ற?
ஃபுல்லா ஸ்ட்ரீம் தான்.
நீயா?
2 இயரா ஸ்ட்ரீம் தான் மதன் ப்ரோ பண்ணுகிறேன்.
2 இயர்ஸா வெறும் ஸ்ட்ரீம் மட்டும் பண்ணிட்டு இருக்க. யுவர் அப்கமிங் யூடியூபரா?
ஆமா மதன் ப்ரோ.
தெளிவா சொல்லு. வாயை பேசு, வாயை தர. கம் ஆன். சே லவுடர். அப்படியா?
2 இயரா வந்துட்டு ஸ்ட்ரீம் தான் மதன் ப்ரோ பண்ணுகிறேன். நீங்க வேணா செக் பண்ணலாம்.
ஆமா பண்ணிட்டு தான் இருக்கேன். 3 months 4 months. ஓ ஆமா. ஏன் இவ்வளவு நாளா ஸ்ட்ரீம்
2
பண்ணிட்டு
இயரா வர்க் போயிட்டு இருந்தேன்.
இவ்வளவு நாளா ஸ்ட்ரீம் பண்ணி என்ன 5000 சப்ஸ்கிரைபர் எடுத்துருக்க? இப்போ வந்து 2-3 மாசத்துக்கு முன்னாடி வந்தவங்கன்னா 100K போயிட்டாங்க. ஏன் வந்து ஷார்ட்ஸ்லாம் நீ போடுறது இல்லையா? போடுற
ஷார்ட்ஸ் நான் போடுறேன் மதன் ப்ரோ.
ஓகே.
வீடியோ போடுறேன், லைவும் போடுறேன்.
755 வீடியோ. சூப்பர். லைவும் போடுற, வீடியோ போடுற. ஓகே.
என்னன்னு தெரியல, நம்ம பக்கம் என்ன குறைன்னு தெரியல.
என்ன குறையா இருக்கும்னு நினைக்கிறேன். என்ன குறையா இருக்கும் இது வரைக்கும் என்ன கண்டுபிடிச்சிருக்கிற? என்ன குறையா இருக்கும்? ஏன் முன்னுக்கு வர முடியல?
மேபி நான் பேசுற ஸ்லாங்கா இருக்கலாம்.
ஏன் நல்லா தானே பேசுற, நல்லா தான் இருக்கு. ஏன் இவ்வளோ நாள் ஸ்ட்ரீம் பண்ணிட்டு இருக்க? இவ்வளோ நாளா ஸ்ட்ரீம் எப்படி வந்து ஒரு முன்னேற்றமே இல்லாமல் இவ்வளோ நாள் ஸ்ட்ரீம் பண்ணுறதுக்கு எது காரணமாக இருக்கு? உன்னோட டெடிகேஷனுக்கு என்ன ஒரு காரணம்? எதை நோக்கி உன்னோட டெடிகேஷன்?
நம்மளுக்கு வெற்றி கிடைக்கும் தான். அதுக்கு நீ எடுத்த உடனே வந்துட்டு எவ்வளோ 2 நாள் 4 நாள் போட்டா வந்துடும் நல்லா இல்லை.
ஓகே. பட் ஆனால் 2 வருஷம் போட்டிருக்கிய.
பரவாயில்ல மதன் ப்ரோ, 10 வருஷம்னாலும் போடலாம்.
10 வருஷம்னாலும் போடுவியா? என்னடா சொல்ற?
அவ்வளோதான்.
ஜெயிக்க வரைக்கும் போராடணும் நீ. ஜெயிக்க வரைக்கும் போராடுவியா நீ?
ஜெயிக்கலனாலும் போராட வேண்டியதுதான்.
ஜெயிக்கலனாலும் போராடுவியா? இது என்னப்பா புதுசா இருக்கு. பரவாயில்லையே.
As you're aware, the hardest part of scraping is actually getting the data that you want from the website, and it's what we've been talking about. People always ask me what they should do, and I say the first thing that you need to do is get yourself a...
ஏன் BGMI? ஏன் கேமிங்?
2 இயரா ஒர்க் போயிருந்த மதன் ப்ரோ.
என்ன ஒர்க் போயிட்டு இருந்த?
ஓகேங்களா, டிவிஎஸ் கம்பெனிக்கு.
என்ன படிச்சிருக்க?
டிவிஎஸ் நான் ஐடி படிச்சிருக்கேன் மதன் ப்ரோ, ஐடி எலக்ட்ரிஷியன்.
ஓகே.
டிவிஎஸ் கம்பெனிக்கு ஒர்க் போயிருந்தேன். அங்கே வந்துட்டு டே ஷிஃப்ட் நைட் ஷிஃப்ட்னு போட்டுருந்தாங்க. சரி, நைட் ஷிஃப்ட்னா கூட அவ்வளோ ஒர்க் இருக்காது நைட் ஷிஃப்ட்ல. அந்த டைமில் என்ன பண்ணுவோம், யூடியூபு இது மாதிரி பார்த்துன்னு ரீல்ஸ் பார்த்துன்னு இருக்கும்போது கேமிங். நானும் அந்த டைமில் பிஜிஎம் விளையாடி இந்த ஃபோனில் இந்த ஷார்ட்ஸ் அதெல்லாம் பார்த்து சரி நாமளும் சும்மா ஃப்ரீயாக இருக்கிற டைமில் போடுவோமே அப்படின்ட்டு அந்த டைமில் போட்டது ஒரு வீடியோ போட்டேன். 1K ரீச் வந்துச்சு ஃபர்ஸ்ட் வீடியோலே. இது மாதிரி வந்துட்டு ஃப்ரெண்ட்ஸ் கிட்ட எல்லாம் சொல்லி சூப்பரா அப்படி இப்படின்ட்டு சொல்லியிருந்தாங்க. அவங்க மோட்டிவேஷன் பண்ணாங்க, அப்பப்போ போடு விட்டுறாது அப்படின்ட்டு. சரி ஓகே போட்டிருந்தேன். சரி லைவ் போடலாம் இந்த இதுக்கு வந்தேன். ஐபேடு வாங்கிட்டேன். சரி லைவ் போடுறதுக்கு வீடியோ ரெக்கார்ட் பண்றதுக்கு இது இல்லை, ஸ்டோரேஜ் பார்த்தல, அதுவும் லேக் வேற ஃபோன்ல.
ஓகே.
அந்த டைம்ல ஐபேடு வாங்கி, அதுவும் வந்துட்டு நானா வாங்கினது தான், வீட்டில் எதுவுமே கேட்கல, நானா வாங்கினது தான். ஐபேட்ல வந்துட்டு வீடியோ ரெக்கார்ட் பண்ணி வீடியோ போட்டு அப்படியே லைவ் ஸ்ட்ரீம் வைஃபை செட் பண்ணி லைவ் ஸ்ட்ரீம் போட்டு ஃப்ரீயா இருக்கிற டைம்ல. அதுக்கப்புறம் 2 இயர் முடிச்சுட்டு இது சர்டிஃபிகேட் வாங்கிட்டேன், எக்ஸ்பீரியன்ஸ் சர்டிஃபிகேட் வாங்கிட்டு நின்னுட்டேன் ப்ரோ.
ஓகே.
இப்போ லைவ் தான் நம்மளுக்கு.
அப்ப இப்ப நீ வேலைக்கே போல, ஃபுல்லா லைவ் தான் பண்ற?
இப்போலாம் லைவ் ஒன்லி யூடியூப் லைவ்.
ஓ ஓகே, சூப்பர் சூப்பர். இப்ப என்ன வந்து என்ன ஏஜ் உனக்கு?
எனக்கு 22 ஆகுது ப்ரோ.
22 ஆகுது. வீட்ல எதுவுமே கேட்கலையா? நீ சம்பாதிக்கவே இல்ல, எதுவுமே கொடுக்க மாட்டேங்கிற, வேலைக்கு போக மாட்டேங்கிறேன்னு சொல்லியா?
சும்மா அப்படிங்களா இல்ல, 2 இயரா போயிருந்தேன். இது மாதிரி வீட்டுல சொன்னேன் எனக்கு பிடிச்சது நான் பண்றேன் அப்படின்ட்டு.
உங்க வீட்ல எதுவும் சொல்லியா?
சரி அவங்க இப்ப ஸ்டார்டிங் வந்துட்டு என்னதுக்கு இதெல்லாம் அப்படின்னு தான் சொல்லியிருந்தாங்க. ஏன்னா நான் ஒரே பையன்றதுனால எப்படி சொல்றது.
ஒரே பையனா?
ஆமா.
அப்பா என்ன பண்றாரு?
அப்பா வந்துட்டு ஃபர்ஸ்ட் இங்க டிவிஎஸ் கம்பெனி பக்கத்துல ஐஎம்எல்னு ஒரு கம்பெனில எம்ப்ளாயா இருந்தாரு.
ஓகே.
பழைய ஆளுங்க வந்துட்டு எடுத்துட்டு புது ஆளுங்களை போடணும் அப்படின்ட்டு எப்படி சொல்றது, எம்ப்ளாயா இருந்தவங்களும் தூக்கிட்டாங்க.
ஓகே.
ஒரு 60 பேரை தூக்கிட்டு கேஸ் போட்டிருக்காங்க.
ஓகே.
அது ஒரு 19 இயரா வயதான் போயினே இருக்குது. இப்போ வந்துட்டு அப்பா செக்யூரிட்டியா இருக்காரு ப்ரோ.
புரியல, செக்யூரிட்டியா?
ஆமா.
எங்க?
ஒரு இந்த கேட்டர் பில்லர் அப்படின்னு ஒரு கம்பெனி இருக்காம.
சரி,
இது
இப்போ உங்க அப்பா செக்யூரிட்டியா இருக்காரு. மம்மி, வாட்ஸ் அ மாம்?
மம்மி இங்க கம்பெனில வேலை.
எனக்கு புரியல. இப்போ அவங்க 2 பேருமே வேலை செய்யறாங்க. அவங்க 2 பேரும் வேலை செஞ்சு ஒண்ணா பாத்துக்கறாங்களா?
நான் இல்ல மருதன் ப்ரோ, நானும் ஒர்க் போயிட்டு நானும் அமௌண்ட் கொடுத்துருந்தேன். இப்போ வந்துட்டு யூடியூப்ல இந்த எப்படி சொல்றது பெய்டு பூஷ் அது மிஷின் ஒர்க் அதெல்லாம்
2 வருஷமா சும்மா தானே இருக்க. இப்போ அப்படி பார்த்தா கூட
2 வருஷமா நான் இது எப்படி சொல்றது நானும் அமௌண்ட் கொடுத்துதாங்கறேன்.
எவ்வளவு கொடுப்ப வீட்டுக்கு?
ஒரு 10k 15k அப்படி.
ஓகே. நீ ஆனா
பண்ணி
இப்போ உங்க அப்பா அம்மா கூட வீட்ல தான் இருக்கியா?
ஆமா,
வீட்ல தான் இருக்க.
ஆமா.
உண்மையாலுமே எதுவும் சொல்லலையா? நீ கேம் விளையாடுறத பார்த்து உண்மையா சொல்லணும், போய் சொல்ல கூடாது.
சத்தியமா சொல்ல. இப்ப என்ன எங்க மம்மிக்கு பேசிக்கிட்டா
பேசு கொடு.
ஒரே நிமிஷம் மா.
பிளேயர்ஸ் ஐடி கம்பெனி ப்ரோ.
உங்ககிட்ட பேசணுமா? உங்ககிட்ட பேசணுமா?
ஹலோ மம்மி.
சொல்லுங்க சார்.
வணக்கங்க. வணக்கம்.
வணக்கம்.
இங்க உங்க பையன் 2 வருஷமா வந்து கேம் தான் விளையாண்டுட்டு இருக்கான், வேலைக்கு போகாம. நானும் நீங்களும் அப்பாவும் அம்மாவும் வேலைக்கு போயிட்டு இருக்கீங்க. இது ஓகேவா உங்களுக்கு? அவன் ஏதாவது ஜெயிப்பான்னு நினைக்கிறீங்களா கேமிங்ல? உண்மையதான் சொல்லணும், நீங்க உண்மையை சொல்லுங்க. ஓகேவா உங்களுக்கு? இது உங்களுக்கு ஓகேவா படுதா?
இது ஓகே இல்லதான். அந்த விளையாட்டு போடானா எங்க போறான், இது என்ன கொஞ்ச நேரம் வேலைக்கு போறோமா அப்படின்றான்.
ஓகே. ஒரே பையன்
அங்க அது
ஒரே பையனால நீங்க அதை விட்டு கொடுக்குறீங்களா இத அவனுக்கு?
ஒரே பையன்றது இல்லப்பா, நம்ம சொல்றத அவங்களும் கொஞ்சம் பார்க்கணும்னு நம்ம விட்டு கொடுக்கணும்ல.
ஓகே. இப்போ மந்த்லி அவன் எவ்வளவு உங்களுக்கு ஏர்ன் பண்ணி உங்களுக்கு ஒரு காசு கொடுத்தா உங்களுக்கு ஹாப்பியா இருக்கும்? அதாவது மந்த்லி ஒரு மாசத்துக்கு இவ்வளவு சம்பாரிச்சா என் பையன் சம்பாரிச்சா நான் சந்தோஷப்படுவேன் அப்படின்னு எவ்வளவு சம்பாரிச்சா பரவாயில்ல உங்களுக்கு?
அவன் கோடியா நம்மளுக்கு சம்பாதிக்கலன்னா போதும். ஏதோ நம்ம வீட்டு இதுக்கு கம்பெனிக்கு போய் செய்யற காசாவது சம்பாரிச்சு கொடுத்தா கூட போதும்.
அதுதான் எவ்வளோன்னு சொல்லுங்க. எவ்வளோ இருந்தா உங்களுக்கு சந்தோஷம் அது சொல்லுங்க.
இன்னைக்கெல்லாம் நாங்க மாசம் ஃபுல்லா நான் போனா ஒரு 15,000 வாங்குறேன்ப்பா.
ஓகே.
என்னுடையது ஒரு 10,000 ரூபாய் செஞ்சு கொடுத்தா கூட போதுமே.
போன மாசம்லாம் உங்களுக்கு 10,000 கொடுத்தேன்னு சொன்னானே, உண்மையா பொய்யா?
கொடுத்தோம் 10,000 அப்பப்ப 4,000 3,000 சேர்த்து கொடுக்குறான்.
ஓகே, கொடுக்குறான். ஆனா அவன் வந்து மாசம் இப்போ மாசம் அவன் ஒரு 25,000 சம்பாரிச்சா உங்களுக்கு சந்தோஷம் கரெக்டா? ரொம்ப சந்தோஷம். கேக்கல
சம்பாரிச்சா போதும்.
அதுக்கு உண்மை இதுதான் கேக்குறோம், அதுக்கு இதுதான் சொல்றோம். அப்படியா? ஓகே ஓகேம்மா, தேங்க்யூ. நீங்க பேசுனது ரொம்ப நன்றி.
சரி.
டேய்
சொல்லுங்க மதன்.
என்னடா உங்க மம்மி வந்து வருத்தப்படுறாங்க நீ வேலைக்கு போலன்னு?
வருத்தெல்லாம் வரல, தூக்கிட்டு எழுந்து வந்து இப்பதான் பேசின்னு இருக்காங்க மதன். வருத்தப்படுறாங்க
பாரு, மாசம் போயிட்டு சம்பாரிச்சா 15,000 தான் கிடைக்குதான். ஒரு நாளைக்கு 500 ரூபா தான் கணக்கு.
ஆமா மதன் ப்ரோ.
நீ எப்படி வந்து இப்படி அவங்க மனசு கஷ்டப்படுத்திட்டு நீ கேமிங் எப்படி சாதிக்க?
நான் இதா இருந்தாலும் ஒண்ணு எனக்கு தான் ஆகணும் மதன் ப்ரோ. ஒண்ணு வேணும்னா ஒண்ணு இழக்கணும்.
சரி ஃபைன், குட்ரா. பட் ஆனா முடியும். உனக்கு வந்து 4 மாசம் டைம். உனக்கு வந்து இஃப் இன் கேஸ் நீ செலக்ட் ஆகாம போகுது அடுத்தது உனக்கு வந்து 4 மாசம் டைம். ஓகேவா? 4 மந்த்ஸ்க்குள்ள நீ சம்பாரிச்சு உங்க அம்மாக்கு 50,000 ரூபாய் இல்லனா 1 லட்சம் கொடுக்கணும். ஏத்துக்கிறியா? இத
கண்டிப்பா 1 லட்சம் கொடுத்தலாம் மதன் ப்ரோ.
கன்ஃபார்மா? 4 மாசம் 120 நாள் தான். கன்ஃபார்ம்
3 மந்த் 4 மந்த்ல 50k தந்தனே மதன்
அதெல்லாம் எனக்கு தெரியாது. உனக்கு 4 மாசம் 120 நாள் டைம். 1 லட்சம் அம்மா கொடுக்குறியா? சவாலா எடுத்துக்கிறியா? சவாலா எடுத்துக்கிறியா?
1 lakh இல்லனாலும் ஒரு 60k 70k நாலும் முடியும்.
ஏதாவது ஒரு அமௌண்ட் கரெக்டா ஃபிக்ஸ் பண்ணு. 4 மாசம் 120 நாள் டைம்.
60 or 70k மதன் ப்ரோ.
4 மாசம் கழிச்சு இதே மாதிரி உங்க மம்மி கேட்பேன் 70000 கொடுத்தானா இல்லையா அப்படின்னு. ஓகேவா?
ஓகே.
உங்க மம்மி கூப்பிடு.
மா வாங்க. ஒரே நிமிஷம்.
முதல்ல உனக்கு 20000 வந்து நாளைக்கு போய் எடுத்துடா டேய். ஸ்கைஓபி. இப்போ நீ அவன தனியா போய் நின்னு அவனுக்கு இப்ப 20000 அனுப்பிச்சிட்டு வா. அவன் வந்துச்சான்னு கேட்டு மறுபடியும் முதல்ல உனக்கு 20000 வந்து நாளைக்கு போய் எடுத்துடா டேய். ஸ்கைஓபி.
கண்டிப்பா மதன் ப்ரோ.
70k இன்னும் 5000 கம்மியா இருக்குது. இந்த மேட்ச் ஜெயிச்சா 10000 80,000 மம்மி எவ்வளவு
டிவிஸ் இது ஒரு ப்ராப்ளமா இருக்கு. உங்களுக்கே தெரியும் 9
அதனால தான் ரெண்டு ஆப்ஷன் நான் யோசிக்கிறேன்னா யோசிக்காம சொல்லவே மாட்டேன். சோலோ யூ கெட் யூஸ். ஏன்னா சோலோல உன்னால மிஷன்ஸ் நிறைய முடிக்க முடியும். உனக்கு இன்னும் ரெவென்யூ நிறைய வரும். யூஸ் உனக்கு நிறைய வரும். ஓகேவா? அதுதான் சொல்றேன். ஓ இது வந்து என்னோட மிஷன்.
உங்க தனிப்பட்ட மிஷன்.
என்னோட தனிப்பட்ட மிஷன். நான் தான் ஆரம்பிச்சேன். அந்த 70,000 நான் என்னோட ஃபர்ஸ்ட் இயர் நான் போடுறேன். ஓகேவா? இது வந்து என்னோட உறுதிமொழி உனக்கு. நீ பிஏடி செலக்ட் ஆகாத அடுத்தது. ஆனா இது நீ பண்ணி ஸ்கையே முடிஞ்சிச்சா? உன்னோட சீசன் உன்னோட முடிஞ்சிச்சு. என்ன ஸ்கையே? ஸ்கைஓபி 30 FPS இருக்கியாடா? மீ எங்க டெவல் இருக்கியா? என்ன நீ என்ன பண்ண? மிஷன் முடிஞ்சிச்சு. வந்து எவ்வளவு சம்பாதிச்சிருக்க இந்த வாரம் வெள்ளிக்கிழமை பண்ணா கூட ஓகே தான். அப்ப உனக்கு எவ்வளவு காசு சேர்த்து வச்சிருக்க தெரியும்? உங்க மம்மி கிட்ட சொன்னா
45k இருக்கு மதன் ப்ரோ.
45k நான் அனுப்புறேன் உனக்கு 60k. ஆனா நம்ம 40k வா 50 70k இன்னும் 5000 கம்மியா இருக்குது. இந்த மேட்ச் ஜெயிச்சா 10000 80,000 மம்மி எவ்வளவு மம்மி நம்ம சவால் விட்டோம்.
75k ப்ரோ.
பரவாயில்ல ஒரு இதா இருக்கற. பின்ன வச்சிக்கிறியா இல்ல போய் சொல்றியா உண்மையாலுமே?
இருக்கு மதன் ப்ரோ.
கையில 45k இருக்கா? ஏமனே 25,000 அனுப்பிச்சிருக்கேன். அதை மட்டும் என்னன்னு கேட்டு அவனை போட்டுட்டு வந்துச்சா? இப்ப நீ அவனு தனியா போய் நின்னு அவனுக்கு இப்ப 20000 அனுப்பிச்சிட்டு வா. அவன் வந்துச்சான்னு கேட்டு மறுபடியும் முதல்ல உனக்கு 20000 வந்து நாளைக்கு போய் எடுத்துடா டேய். ஸ்கைஓபி. கங்க்ராச்சுலேஷன். இந்த மிஷன்ல வந்து ஆஸ் 2 முடிச்சதுக்கு 220,000 ஆட்டை போட்டதுக்கு கங்க்ராச்சுலேஷன். ஓகே
ஆன் பண்ணிட்டு மதன் ப்ரோ.
எடுத்துட்டியா? காசை எடுத்துட்டியா? என்னடா வெரியா? ஹாய் மம்மி. வெரியா உட்காந்து என்னடா வேற மாதிரி வச்சிருக்க? வெரி நல்லா இருக்கீங்களா?
65,000 கொடுக்குறான்பா.
65,000 கொடுத்தா உங்களுக்கு சந்தோஷமா?
2 மாசத்துக்கு வாடகை கொடுத்துறான்.
ஓ அப்படியா? உங்களுக்கு இப்ப ஹாப்பியா?
முடிச்சிட்டான்.
ஹாப்பியா?
ஹாப்பி.
ஹாப்பி. சரி இப்போ வந்து அவன் வந்து ராத்திரி பகல் விளையாண்டான். உண்மையா சொல்றேன் ரொம்ப எஃபர்ட் போட்டான். அவ்வளவு நேரம் விளையாண்டான். மிஷன்
பகல் சாப்பிடுறது இல்ல, தூங்குறது இல்ல, நல்ல தூக்கம் கிடையாது அவனுக்கு.
ஆமா.
எவ்வளவு கஷ்டப்படுறான் நைட்டு போதுல.
வெரி
கம்பெனி போனா கூட இவ்வளவு
கஷ்டப்பட முடியாது. ஆனா இது ஈஸி கிடையாது. கஷ்டமான வேலை தான். ஆனா வந்து நம்ம இது பண்ணலாம். இப்போ உங்களுக்கு வந்து ஒருவேளை அவன் நம்பிக்கை வந்திருக்கா? இப்போ வந்து அவன் பண்ணட்டுமா இத? பண்ணட்டும். உங்களுக்கு சந்தோஷம் தானே? நீங்க எவ்வளவு சம்பாதிச்சா நீங்க வேலைக்கு போறது பண்ணி நீங்க வீட்ல வந்து ஹாப்பியா இருப்பீங்க? சொல்லுங்க. அன்னைக்கு நீங்க எவ்வளவு தைரியமா சொன்னீங்களோ அதே மாதிரி நீங்க தைரியமா சொல்லுங்க. நீங்க எவ்வளவு என்ன வேணா சொல்லலாம் என்கிட்ட.
இப்ப எப்படி செஞ்சதுன்னா நான் இதெல்லாம் அதிகமா தரேன். நான் அவன் வேணாமா நின்னுக்குமானா நான் சந்தோஷமா நின்னுக்குவேன் வேலைய விட்டு.
அப்படியா? ஓகே. ஷாப்பிங் நீங்க ஜாலியா ஓகே. சரி எல்லாமே சந்தோஷம். இப்போ நீங்க ஒரு இப்போ இந்த மறுபடியும் சொல்லுங்க. இந்த அடுத்த 3 மாசத்துல அவன் என்ன பண்ணனும் அப்படி சொல்லுங்க. வேற ஏதாவது எனக்கு இது பண்ணி தரணும் அவன் அப்படி சொல்லுங்க. அதையும் பண்ண வைக்கிறோம்.
என்ன எனக்கு இது கொஞ்சம் நகை வச்சிட்டுக்கறேன். பேங்க்ல வீட்டு பிரச்சனைக்கு அது வாங்கி தந்தறானா போதும்.
எவ்வளவு வச்சிருக்கீங்க?
1.5 லட்சம் வச்சிருக்கேன்பா.
வச்சிருக்கீங்க. 1.5 லட்சம் சம்பாதிக்கணும் நீங்க அட்லீஸ்ட் ஒரு 5 மாசம் டைம் கொடுங்க பரவாயில்லையா?
தரேன்.
ஓகே 5 மாசத்துல வந்து 1 லட்சம் சம்பாரிச்சு உங்களுக்கு உங்க நகையை மீட்டு நீங்க நகை போடணும். கரெக்ட்டா? சொல்லுங்க அவங்க சொல்லுங்க இப்போ. நீங்க சொல்லுங்க அவங்க சொல்லுங்க. 5 மாசத்துக்குள்ள நீங்க 1 லட்சம் வாங்கி கொடுக்கணும்டா அப்படி சொல்லுங்க அவங்க கிட்ட. சொல்லுங்க. 5
மாசத்துல 1 லட்சம் ரூபாய் சம்பாதிச்சு நகை மூட்டி என் கையில கொடுக்கணும்.
என்னடா 30 பைசா? ஓகேவா? உங்க மம்மி சொல்றது ஓகேவா? கேளுங்க அவங்க கேளுங்க. ஓகேவா கேளுங்க அவங்க கிட்ட.
ஓகேவாப்பா?
என்ன சொல்றான்?
சொல்ல. கண்டிப்பா பண்ணிடலாம்.
கண்டிப்பா பண்ணிடுவானே.
கேட்டான்னு சொல்றேன்.
மம்மி நீங்க நல்லா ஞாபகம் அவன் வந்து ஜெயிச்சு அவன் 5 மாசத்துல மிஷன் முடிச்சு அவன் வந்து கண்டிப்பா உங்களுக்கு வந்து உங்க நகை மீட் தரணும். இதுதான் அடுத்த 5 மாசத்துக்கு அவனோட வேலை. ஓகேவா? மீட் தந்துடணும். அது ரொம்ப முக்கியம். வேலைக்கு போய் உன்னை வளர்த்துக்காங்க எல்லாம் பண்ணிடுவாங்க. அடுத்த 5 மந்த்ஸ் உங்களோட வேலை தான். ஆல்ரெடி சோலோ மிஷன் அவர் கொடுத்துருக்காரு. அதுக்கு 25,000 மீதி 125 நீ என்ன வேணா பண்ணிக்கலாம். என்ன சூப்பர் என்ன பண்ணிக்கோ. ஆனா பண்ணி ஆகணும். ஓகேவா?
ஓகே ப்ரோ.
சரி ஓகே. ரொம்ப ஹாப்பி டாடி. சூப்பர் டூப்பர் செமையா பண்றா.
ஓகே ப்ரோ. தேங்க் யூ.
சரியா ஃபைட் பண்ணிட்டு வாடி. ஒரே ஒரு பிஸ்டல் வச்சிக்கினு. என்னடி இது? என்ன இதுதானே? கை எடுத்துட்டு ஆனாலும் மட்டும் கையிலே வெடிஞ்சிச்சு. நை பாரு நீ அப்படியா? கேட்டுங்க பாரு. தேடி ஜோன். இந்த ஜோன் முடிஞ்சாலும் நான் போக மாட்டேன். இந்த ஜோன் தான் போகணும். அது பிஆர்டி எடுத்து என்ட்ரி. அப்பதான் என்ட்ரி கொடுப்பேன்.
Por ataque físico,
तुम।
किधर से आएगा भाई बीआरडीएम से? अबे नहीं मरा। अबे भाई क्या क्या है ये? अबे भाई क्या क्या है ये?
Regarding layer. Generally, we know that sender sense. In this video, we are going to discuss about cyclic redundancy check. In short, we can call it as CRC. CRC is mainly useful for error detection in data link layer. Generally, we know that sender sense. In this video, we are going to discuss about checksum. Checksum is an error detection technique. Generally, sender sends a message to the receiver, but there is a possibility that some of the bits in the message may be lost or some of the bits in the message may be changed. So in this occasion, in order to detect the error at the receiver side, so receiver uses some error detection technique called checksum. Okay, so checksum is mainly useful for error detection. Let's see what will happen in the checksum. At the sender side, what will happen is initially the message is divided into n segments. The first point is the message is divided into n segments, where each segment contains m bits. So let us assume that message is divided into n segments, where the size of each segment is m bits. Okay, so here the size of the message is 32 bits. It is divided into 4 segments: segment 1, segment 2, segment 3, segment 4, where each segment size is 8 bits. Where each segment size is 8 bits. And the second step is we add all the segments. So we have to add all the segments. Okay, so one by one. Okay, so first we add these two segments and we get some sum. Add that sum to the next segment like that. Okay, we add all the segments. We have 4 segments are there. So perform sum operation on all the segments. And the third step is if carry is 1. Okay, if carry is 1. Okay, after adding all the bits, after adding more significant bits, we will get some carry. If carry is 1, then we add it to the LSB of the sum. Okay, we add it to the LSB of the sum. Then after that, so after adding all the segments, we will get some value. If we complement the sum, then we will get the checksum. So how do we get the checksum? So we will get the checksum by complementing the sum value. By complementing the sum value. And the last step is the sender sends the message. The sender sends all the 4 segments. The sender sends the entire message with the checksum. Okay. So message plus checksum will be sent to the receiver. Okay. Will be sent to the receiver. Now let us do all the activities. And plus checksum will be sent to the receiver. Okay. Will be sent to the receiver. Now let us do all the activities. And after that, we will discuss about at the receiver side what will happen. Okay. So first, what will happen? We have to divide the message into n segments, where each segment contains 4 bits. So already first there, 32 bits of the message is divided into 4 segments, where each segment size is 4 bits. Okay. Where each segment size is n bits. Okay. So we have to add it to the LSB of the sum. LSB of the sum. Okay. So next, first step is over. What is the second step? Add all the segments. So what is the first segment? 101, 1011, 0011. So this is the first segment. 1011, 0011. And what is the second segment? 1010, 1010, 1011. So we add all the first add these 2 segments. So 1 plus 1 means 0 carry 1. 3 1 means sum is 1, carry is 1. 0, 0, 1 means sum is 1, carry is 0. So 0 plus 1 means 1, 1 plus 0 means 1, 1 plus 1 means 0 with the carry 1, 1 plus 1 means 0 with the carry 1. So after getting the sum, if the carry is 1, then what we have to do? If carry is 1, then we have to do the least significant bit of the sum, okay? So we have to add this one to the least significant bit of the sum. So 0 plus 1 means 1, there is no change in the remaining bits. So keep all of the bits as it is. So 0, 1, 0, 5 ones, okay? So first two segments are added. Now let us add third segment to the sum. So what is the third segment? 0, 1, 0, 0, 1, 0, double 1, 0, 1, 0, 0, 1, 0. So you add third segment to the sum. So 1, so 0, 1, 0, 1, 1, 0, 1, 0, okay? 1 plus 1 means 0 with the carry 1, 1 plus 1, 0 with the carry 1, triple 1 means 1, 1, triple 1 means 1, 1, 1 plus 1 means 0 with the carry 1, 1. Here we don't have any carry, so there is no need to add to the sum. What is the fourth segment? What is the fourth segment? 1, 1, 0, 1, 1, 1, 0, 1, next to 0, 1, 0, 1, 0, 1, 0, 1. So 1, 1, 0, 1, 0, 1, 0, 1, okay? Next 1 plus 1 means 0 with the carry 1, 1, 1, 1, 0 with the carry 1, 1, 1, 0 with the carry 1. Here the carry is 1, so we have to add this carry to the least significant bit of the sum. So 0 plus 1 means 1, there is no change in remaining bits. So 0, 1, 0, so triple 1, 1, okay? So this is the message, this is the sum that we got after adding all the segments. So second step is over, third step is over. Let's see the fourth step. So how we can get the checksum? By complementing the sum. So we get the checksum by complementing the sum. So checksum is equal to, so complement the sum. So 0 will be converted to 1, 1 will be converted to 0. So 1, 0, 0, 1, 1, 4 zeros, okay? So 1, 0, 0, 1, 0, 0, 0, 0. So this is nothing but checksum. So what is the checksum? Here I am getting the checksum. So 1, 0, 1, 1, 0, 0, 1, next to 4 zeros, okay? Now what we have it? The sender sends these messages along with the checksum. Now at the receiver side, we have 5 segments. So these 4 segments are nothing but the message, whereas the fifth segment is nothing but the checksum. So now let us 0, 1, 0, remaining bits. So 0, 1, 0, so triple 1, 1, okay? So this is the message, this is the sum that we got after adding all the segments. So second step is over, third step is over. Let's see the fourth step. So how we can get the checksum? By complementing the sum. So we get the checksum by complementing the sum. So checksum is equal to, so complement the sum. So 0 will be converted to 1, 1 will be converted to 0. So 1, 0, 0, 1, 1, 4 zeros, okay? So 1, 0, 0, 1, 0, 0, 0, 0. So this is nothing but checksum. So what is the checksum? Here I am getting the checksum. So 1, 0, 0, 1, 1, 0, 0, 1, next to 4 zeros, okay? Now what we have it? The sender sends these messages along with the checksum. Now at the receiver side, we have 5 segments. So these 4 segments are nothing but the message, whereas the fifth segment is nothing but the checksum. So now let us write the steps at the receiver side, okay? So what we have at the receiver side, okay? What we have at the receiver side, okay? So here a receiver receives 5 segments. The entire message with 4 segments as well as what we have at the receiver side, okay? So here a receiver receives 5 segments. The entire message with 4 segments as well as checksum, okay? So it performs addition operation on all the segments. So you add all the segments. So totally how many segments are there? 5 segments. So these are the 4 segments of the message and the fifth segment is checksum. So you add all the segments. Here also same thing. If carry is 1, then you add it to the sum. If carry is 1, you add it to the sum. Then you add it to the MST of the sum. You add it to the MST of the sum. So same thing. Next one is after performing the addition operation, we will get this sum. Then how will we get the checksum? You know how will we get the checksum? Checksum is obtained by complementing sum. Checksum is obtained by complementing the sum. If the result is 0, if the result is all zeros, so totally we will get 8 zeros. If the result is zeros, then the message will be accepted by the receiver. Suppose if the message contains some ones, then it specifies that there is an error. So in this way, receiver detects the error with the help of this checksum technique. Okay. So now already all the bits are added. Already we have added the 4 segments. So after adding 4 segments, segment 1, segment 2, segment 3, segment 4. After adding all the segments, we got the result as complement of this checksum. So 0, 1, 1, 0, 4 ones. Okay. So this is nothing but checksum. So checksum means what? Complement of sum. Okay. So that was already arranged. So So 0, 1, 1, 0, 4 ones. Okay. So this is nothing but checksum. So checksum means what? Complement of sum. Okay. So that was already arranged. So after adding all the 4 segments, we got this message 0, 1, 1, 0, 0, 1, 1, 0, 4 ones. So now we have to add, now these 4 segments are added. After adding these 4 segments, we got the sum. So now what we have to do? We have to add the fifth segment. That is nothing but checksum to the sum value. So what is the checksum? 1, 0, 0, 1, 4 zeros. 1, 0, 0, 1, 4 zeros. Let us perform the addition. So 1, 1, 1, 1, 1, 1, 1, 1. Okay. So here, so you add all the segments. 4 segments are added. This is the result here. If the carry is 1, so that was done here only. How we can get the checksum? We can get the checksum by complementing the sum. So let us complement the sum. So if you complement the sum, what will happen? All ones are converted to all zeros. So now we got 8 zeros. If the result is all zeros, then the receiver comes to know that it is the correct message. So there is no change in the message. So receiver accepts that message and provides the acknowledgement. Suppose if some of the bits are lost, then what will happen is the result may contain some zeros. So if you complement the zeros, then what will happen? If you complement the message, then what will happen? So ones are converted to zeros, zeros are converted to ones. So we get the message as like this. Okay. After complementing this one, okay. If the message contains some ones, so receiver comes to know that some bits are changed in the message. So receiver sends a message to the sender to transmit that message one more time. So with the help of this technique, we can do only the error detection. Error detection cannot be done. In order to detect and correct the error, we will use the timing code technique that we will discuss in the next. With the help of this checksum technique, okay. So now already all the bits are added. Already we have added the 4 segments. So after these 4 segments, we got the sum. So now what we have to do? We have to add the fifth segment. That is nothing but checksum to the sum value. So what is the checksum? 1, 0, so you add all the segments. 4 segments are added. This is the result here. If the carry is 1, so that was done here only. How we can get the checksum? We can get the checksum by complementing the sum. We can get the checksum by complementing the sum. So let us complement the sum. So if we complement the sum, what will happen? All ones are converted to all zeros. So now we got 8 zeros. Then what will happen? If we complement the message, then what will happen? So ones are converted to zeros, zeros are converted to ones. So we get the message as lines. Okay. After complementing this one, okay. Here the message contains some ones. So receiver came to know that some bits are changed in the message. So receiver sends a message to the sender to transmit that message one more time. So with the help of this technique, we can do only the error detection. Error correction cannot be done. In order to detect and correct the error, we will use the timing code technique that we will discuss in the next. A message to the receiver. In this video, we are going to discuss about parity check. This method is mainly useful for error detection. So we have error detection and error corrections are there. So parity check is useful for error detection. Even parity. First one is even parity. Even parity. So likewise, we can do the odd parity also. Okay. So for that, let us do one more example. So 1 0. Let us do the odd parity. Okay. 1 0 1 0. Net size of the message is 4 bits. Net size of the message is 4 bits. Here we are using which parity? We are using odd parity. So what is odd parity? Odd parity means the number of ones should be odd. Okay. But here how many ones are there? 2 ones are there. 2 means it is not an even number. So but there is a possibility that some of the data may be lost in the corresponding message. In that occasion, how the receiver detects the error. In order to detect the error, mainly we have two approaches are there. In this video, we are going to discuss about cyclic redundancy check. In the upcoming video, we'll see about parity check method. That is also useful for error detection process. Okay. Let us see about what is CRC. So CRC means cyclic redundancy check. In this example, we have a frame. So this is nothing but the message. The sender wants to send this message to the receiver. But there is a possibility that some of the data of the message may be lost due to any error, due to some noise. Some of the bits may be lost. So in that occasion, the receiver rechecks whether that is the right message or not with the help of the CRC approach. Now let's see here. This is nothing but frame of the message. So this is the frame here, and this is nothing but CRC generator. And generator is nothing but this is nothing but division. The size of the division is 5 bits here. Here at the center side, what we have to do is we have to perform division operation on the division and the dividend. So here division is nothing but 10011. So this is nothing but CRC generator. Whereas dividend is nothing but the frame or message that we want to send. Okay. So after performing the division operation, we will get some reminder. Okay. We will get some reminder. So what the sender will do is sender will appends that reminder to the frame and sends that message to the receiver. Now at the receiver side, receiver performs division operation on this approach. Now let's see here. This is nothing but frame of the message. So this is the frame here, and this is nothing but CRC generator. And generator is nothing but this is nothing but division. The size of the division is 5 bits here. Here at the sender side, what we have to do is we have to perform division operation on the division and the dividend. So here division is nothing but 10011. So this is nothing but CRC generator. Whereas dividend is nothing but the frame or message that we want to send. Okay. So after performing the division operation, we will get some reminder. Okay. We will get some reminder. So what the sender will do is sender will appends that reminder to the frame and sends that message to the receiver. Now at the receiver side, receiver performs division operation on this generator or division and the new frame. So what is the new frame? The same message only, but in relation to that, it has the corresponding reminder value. Okay. The corresponding reminder value. At the receiver side, if receiver got reminder as 0, then the receiver can know that it is the correct message. So there is no problem. Suppose if the receiver didn't get the reminder as 0, then it sends an acknowledgement to the sender that please send that message one more time. Okay. So this is the approach here. So initially here we have to determine the size of the generator or size of the division. Here size of the division is 5 bits. So we have to add 5 minus 1. That is nothing but 4 zeros. So we have to add 4 zeros to the frame. Okay. We have to add 4 zeros to the frame. So let us do that. So what is the message now? 1101. So 1101 01 110101. Next 1011. So 1011. So this is the frame or message sender wants to send this to the receiver. So what we have to do, in addition to the message, the sender has to add 4 zeros to the message. Why? Because the size of the generator is 5 bits. So 5 minus 1 means 4 bits. Okay. So the sender has to add 4 zeros to the message. So sender will add 4 zeros to the message. 4 zeros to the message. This is nothing but dividend value. Whereas what is the division value? This is the division value. So 10011. 10011. Now simply we have to perform the division operation. So here what is the most significant bit value? 1. Okay. So we have to perform multiplication with 1. So 10011. So next we have to perform the subtraction operation. Here the subtraction is nothing but exclusive OR operation only. We know what is exclusive OR operation. If both the bits are same, the result is 0. Whereas if the sender has to minus 1, that is nothing but problem. Suppose if the receiver didn't get the reminder as 0, then it sends an acknowledgement to the sender that please send that message one more time. Okay. So this is the approach here. So initially here we have to determine the size of the generator or size of the division. Here size of the division is 5 bits. So we have to add 5 minus 1. That is nothing but 4 zeros. So we have to add 4 zeros to the frame. Okay. We have to add 4 zeros to the frame. So let's do that. So what is the message now? 1101. So 1101. 0 1 1 1 0 1 0 1. Next 1 0 1 1. So 1 0 1 1. So this is the frame or message sender wants to send this to the receiver. So what we have to do, in addition to the message, the sender has to add 4 zeros to the message. Why? Because the size of the generator is 5 bits. So 5 minus 1 means 4 bits. Okay. So the sender has to add 4 zeros to the message. So sender will add 4 zeros to the message. 4 zeros to the message. This is nothing but dividend value. Whereas what is the division value? This is the division value. So 1 0 0 1 1. 1 0 0 1 1. Now simply we have to perform the division operation. So here what is the most significant bit value? 1. Okay. So we have to perform multiplication with 1. So 1 0 0 1 1. So next we have to perform the subtraction operation. Here the subtraction is nothing but exclusive OR operation only. We know what is exclusive OR operation. If both the bits are same, the result is 0. Whereas if both the bits are different, the result is 1. Okay. So here what are the here 0 0. Both the bits are same. So result is 0. 1 1 0 0. 1 1 both the bits are same. Result is 0. Here 1 1 both the bits are same. Result is 0. Okay. Next here 1 0 both the bits are different. Result is 1. 0 1 both the bits are different. Result is 1. Here we should not consider leading zeros here. We should not consider zeros here. Here the most significant bit should always start from 1 only. Okay. Here before this one we have a leading zero, so we have to omit this one. Okay. So next we have to here what is the size of the division? 5 bits. Whereas here we have only 4 bits are there. The most significant bit should always start from 1 only. Okay. Here before this one we have a leading zero, so we have to omit this one. Okay. So next we have to here what is the size of the division? 5 bits. Whereas here we have only 4 bits are there. So let us take the next bit from the message, that is 1. So here what is the first bit? 1. So 1 0 0 into 1 1 is nothing but 1 0 0 1 1. Here there is no need of any quotient. There is no need to write any quotient here. Why? Because our main target is finding out the remainder here. Okay. So here all the bits are same. 1 1 means 0, 1 1 means 0, 0 0 0 because both the bits are same. If both the bits are same, the result is 0 only. Here all are zeros only. All leading symbols are zeros only. So we have to omit all the zeros. Why? Because the most significant bit, the leading bit, should always start from 1 in the message. Okay. So we have to copy the next 5 bits. Why? Because the size of the division is 5 bits. Okay. So copy this one 1. So copy this one 0. Copy this one 1. So copy this one 1 4 bits. Next copy the next bit. Okay. That is 0. So 1 0 1 1 0. Okay. So 1 into 1 0 0 1 1 is nothing but 1 0 0 1 1 1 0 0 1 1. Next we have to perform the exclusive OR operation. So first check whether any bits are same or not. Here 1 1 both the bits are same. If both the bits are same, then result is 0. Next 0 0 both the bits are same. Result is 0. Next here also 1 1 both the bits are same. Result is 0. Next 1 0 different. So result is 1 0 1 different. So result is 1. Okay. So here we have 2 zeros. Here we have 2 leading zeros. So we have to reject these 2 zeros. So next we have 3 bits only. But here what is the size of the division? 5 bits. So we have to take 2 more zeros from the message. So copy these 2 bits here. Okay. Next here the most significant bit is 1. So 1 into 1 0 0 1 1 1 0 0 1. So next we perform the exclusive OR operation. Here both the bits are same. If both the bits are same, the result is 0. Next here here all the bits are different. So 1 1 1. So we have to ignore these 2 zeros. So next what is the next bit here? So the next bit is 0 now. So the next bit is 0 now. So now this dividend contains, I'm sorry, this is nothing but the remainder. So remainder contains how many bits? The remainder contains 4 bits now. Whereas what is the size of the division? The size of the division is 5 bits. So that means division has larger value than its message. So no subtraction. That is exclusive OR. No subtraction is not possible here because division is larger than the message. So here we got CRC bits. So what are the CRC bit? 3110. Okay. Now we have to append this 3110 to the message and transmit that message to the receiver. So what are the CRC bit? 3110. Okay. Now we have to append this 3110 to the message and transmit that message to the receiver. Okay. So at the receiver side, what we have now. So let us do the proceedings at the receiver side. So 1 1 1. So we have to ignore these 2 zeros. So next what is the next bit here? So the next bit is 0 now. So the next bit is 0 now. So now this dividend contains, I'm sorry, this is nothing but the remainder. So remainder contains how many bits? The remainder contains 4 bits now. Whereas what is the size of the division? The size of the division is 5 bits. So that means division has larger value than its message. So no subtraction. That is exclusive OR. No subtraction is not possible here because division is larger than the message. So here we got CRC bits. So what are the CRC bit? 3110. Okay. Now we have to append this 3110 to the message and transmit that message to the receiver. Okay. So at the receiver side, what we have now. So let us do the proceedings at the receiver side. So now we are doing at the receiver side. So at the receiver side, same. What is the message? 1 1 0 1 0 1 0 1 1 0 1 1. Okay. But previously we have appended 4 zeros at the sender side. We are there to find out the remainder. Now in place of those 4 zeros, we have to append these 4 bits. 3110. We have to append the remainder. So 3110. Okay. Next here, the division or generator must be same only. Initially both the sender and the receiver will change the division value or generator value. The value should be same at both sender and the receiver side. So here what is the division value? 1 0 0 1 1. So if we got remainder as 0, then the receiver will conclude that sender there is no error in the message. The message is the correct one. Okay. Suppose if the receiver didn't get remainder as 0, then it came to know that there is some error. So it asks the sender to transmit that message one more time. Okay. So here the most significant bit is 1. So 1 into 1 0 0 1 1. Okay. Next we perform the exclusive OR operation. Here both the bits are same, result is 0. Here both the bits are same, result is 0. Both the bits are same, result is 0. Next here different 1, so different 1. Okay, so always we have to ignore 0 here. The leading zeros are always ignored. So here we have 4 bits. So we have to copy the next bit, but because the size of the region is 5 bits. Okay, next here 1 into 100 that is nothing but 100 here all the bits are same only. So the result is all zeros. So next we have to copy the next 5 bits from the message. So 1 0 1 0 0 1. Okay, 1 0 0 1. So copy this message. Now we have to ignore all these zeros. Okay, so 1 into 100 is nothing but 100. So now perform the exclusive operation. So both the bits are same 0, both the bits are same 0. Here also both the bits are same 0. Here also both the bits are same. Result is 0. Here 1 plus 0, both the bits are different. So 1. Okay, so next what we have to do? We have to ignore the leading 2 zeros. Here we have 3 bits in the division. So we have to copy the next 2 bits. So the next 2 bits are 1 1. So copy these 2 bits. So here the most significant bit is 1 only. So 1 into 100 is nothing but all zeros only. All zeros only. Next copy the next bit. Here we got the remainder as 0. So now the receiver knows that there is no error in the message. Okay, so in this way we can use cyclic redundancy as 1 only in order to know. We are going to discuss about having code. Having code is an error detection and correction approach. So by using having code technique, we can detect the error as well as we can correct the error also. Error detection and correction approach. Generally, we know that sender sends a message to the receiver. There is a possibility that some of the bits in the message may be lost, or some of the bits in the message may be changed. Some zeros will be converted to 1 and 1 will be converted to zeros. Okay. In that direction, the receiver can detect the error with the help of having code approach, as well as the receiver can detect can correct the error also. So in which position the error was produced. Okay, the correction will also be done with the help of the having code approach. Okay, so now let us see how we can implement the having code approach. Let us assume that here the message is represented by m, where the message may contain any number of bits. It may be 4 bits or 8 bits or 16 bits or 32 or 64 bits. But for our comfortable purpose, but for simple example, I am taking the size of the message as 4 bits. Okay, I am taking the size of the message as 4 bits. In this example, let message is 1010. 1010. So in this approach, what will happen is sender sends the message with parity bits. Okay, so some parity bits will be added to the message. These parity bits will also be called as redundant bits. Parity bits are also called as redundant bits. Redundant means some extra bits will be added. Okay, so what the sender will do? Sender sends the message with parity bits to the receiver. So how many parity bits will be sent? Okay, so how many parity bits will be sent? That depends upon the message here. So how many parity or redundant bits will be sent? So for that purpose, we use a formula. The formula is this one: 2 power r is greater than or equal to m plus r plus 1. So in order to know how many parity bits the sender has to send, it uses this formula. Okay, here r means redundant bits, number of redundant or parity bits. M means the size of the message. In this example, the size of the message is 4 bits. So let us assume that r value is 1. If r value is 1, then 2 power 1, that is 2 is greater than or equal to, what is m? 4 bits. What is r value? 1. So 4 plus 1 plus 1. 4 plus 1 plus 1. So that is nothing but 6. 2 greater than or equal to 6. This condition is false. So r should not be 1. Let us consider that let r is 2. Then what will happen? 2 power 2. 2 power 2 means 4. So 4 is greater than or equal to, what is r value now? 7. 4 plus 2 plus 1 means 7. So 4 is greater than or equal to 7. This condition is also false. Now let us assume that r is 3. So 2 power 3. 8 is greater than or equal to 4 plus what is r value? 3. So 4 plus 3 7. 7 plus 1 8. So 8 is greater than or equal to 8. We have greater than as well as equals to. So 8 is greater than or equal to 8. Condition is 2. Okay. So the number of redundant bits are 3. So the sender has to send the message as well as it have 3 parity bits to the sum and it send it to the receiver. Okay. So how many parity bits the sender has to add? That depends upon the size of the message. If the size of the message is 4 bits, then we have to send 3 bits, 3 parity bits. Whereas if the size of the message is 16 bits, then r value are 4 plus what is r value? 3. So 4 plus 3 7. Number of redundant bits are 3. So the sender has to send the message as well as it can add 3 parity bits to the sum and it send it to the receiver. Okay. So how many parity bits the sender has to add? That depends upon the size of the message. If the size of the message is 4 bits, then we have to send 3 bits, 3 parity bits. Whereas if the size of the message is 16 bits, then our value or the parity bit value there is some other value. Okay. So in which position we have to add the parity bits? Generally, parity bits will be added. Parity bits will be added. Yet powers of 2. So at powers of 2, the parity bits will be added. So powers of 2 means the first power is 2 power 0, second power is 2 power 1, third power is 2 power 2 like this. Here we have 3 parity bits only. So that's why these 3 positions are enough. Okay. You know what is 2 power 0? 2 power 0 means 1, 2 power 1 means 2, 2 power 2 means 4. Okay. Now let us write the message now. Let us construct the 4 word is 3 positions are enough. Okay. You know what is 2 power 0? 2 power 0 yet power or the parity bit value there is some other value. Okay. So in which position we have to add the parity bits? Generally, parity bits will be added. Parity bits will be added. Yet powers of 2. So at powers of 2, the parity bits will be added. So powers of 2 means the first power is 2 power 0, second power is 2 power 1, third power is 2 power 2 like this. Here we have 3 parity bits only. So that's why these 3 positions are enough. Okay. You know what is 2 power 0? Zero. 2 power 0 means 1. 2 bits. Whereas bits the sender has to add. That depends upon the size of the message. If the size of the message is bits, then we have to set 3 bits, 3 parity bits. Whereas if the size of the message is 16 bits, then our value or the parity bit value there is another value. Okay. So in which position we have to add the parity bits? Generally, parity bits will be added. Parity bits will be added. Yet powers of 2. So at powers of 2, the parity bit will be P2. So this is the message, and where the parity bits will be there at 1 position. So at 1 position we have P1 parity bit. Next at 2 position. At 2 position we have parity bit 1 0. So now we have to determine what is P1, what is P2, what is P3. Here, how many parity bits are there? 3 parity bits are there. So the size of the parity bit is 3. So 3 means with 3, how many numbers the sender can send? 2 power 3 numbers. 2 power 3. So what is 2 power 3? 8 numbers. 8 numbers the sender send. Okay. So totally we can have 8 combinations. The minimum value is 0. So from 0 to 7, we have some parity bits. Okay. So 0, 1, 2, 3, 4, 5, 6, 7. Okay. So these are nothing but decimal numbers. And the corresponding parity bits are P1, P2, P3. So how we can represent 0 in parity notation? 0, 0, 0, 1, 0, 0, 1, 2, 0, 1, 0, 3, 0, 1, 1, 4, 1, 0, 0, 5, 1, 0, 1, 6, 1, 1, 0, 7, 1, 1, 1. So these are nothing but positions. Now we have to determine what is P, what is P2, what is P3. Let us determine what is P1. Here we are using the even parity. So here also the Hamming code may uses either even parity or odd parity. Even parity means the number of ones should be even, whereas odd parity means the number of ones should be odd. Okay. So for that purpose, here we are finding what is P1 value. So we have to observe this column where ones are here. Okay. So 1 is available here, number 1. Okay. So 1 comma. Next 1 is available here, third position. 3 comma. 1 is available here, fifth position. 5 comma. 1 is available here, 7. So with the help of these 4 bits, we can get P1 value. Now let us analyze where what is P2. So for that purpose, we have to determine, we have to check P2 comma where ones are there. So 1 is available here, 2 position. Next 1 is available here, 3 position. 1 is available here, 6 position. Next 1 is available here, 7 position. Now let us check what is P3 value. So for that we have to observe this column. So we have 1 here, 4, 5, 6, 7 positions. So 4, 5, 6, 7 positions. Okay. So these are the different positions. These are the different parities. Okay. So now let us check. Let us observe what is P1. So 4, 5, 6, 7 positions. Okay. So these are the different positions. These are the different parities. Okay. So now let us check. Let us observe what is P1, what is P2, what is P3 values. So P1 is equal to P1 is equal to. So what is 1? So at 1 we have P1. At 1 we have P1. At third position we have 0. At fifth position we have 1. At seventh position we have 1. Okay. At 1 position 1357. At 1 position we have P1. At 3 position we have 0. At 5 position we have 1. At 7 position we have 1. Here the sender and the receiver, before sending the message, they both agree which target they want to use. Let us assume that here. So at 1 we have P1. At 1 we have P1. At third position we have 0. At fifth position we have 1. At seventh position we have 1. Okay. At 1 position 1357. At 1 position we have P1. At 3 position we have 0. At 5 position we have 1. At 7 position we have 1. Here the sender and the receiver, before sending the message, they both agree which target they want to use. Let us assume that here both agreed to use the even target. Even target means the number of ones should be even. If you count here how many ones are there, 2 ones are there already. So it adds 0 to the message, so that there will be no change in number of ones. So after adding this 0 also, the number of ones are 0 only. The number of ones are 0 only. So that means the value of P1 is 0. The value of P1 is 0. Now let us check what is P2 value. So what is P1 value now? 1. Okay, let us say what is P2 value. So after finding P1, P2, P3, we substitute those values. So what is P2? 2, 3, 6, 7 positions. So at 2 we have P2. At 3 position we have 0. At 6th position we have 0. At 7th position we have 1. Okay. P2, 2, 3, 6, 7. At 2nd position we have P2. At 3 we have 0. At 6 we have 0. At 7 we have 1. Okay. Here we are using the evenality method. So the number of ones should be even. Whereas here the message contains only 1. So we have to add one more 1. We have to make this one as even. Okay. So what is P2 value? So P2 value should be 1. So what is P1 value? P1 value is 0. What is P2 value? What is P2 value? P2 value is 1. Next let us calculate what is P3. So we calculate P3 with the help of the positions 4, 5, 6, 7. So what are 4, 5, 6, 7? P3 1, 0, 1. P3 1, 0, 1. So here number of ones are already even only. So P3 value is 0. So after adding this 0, there is no change. So what is P3 value? The value of P3 is 0. The value of P3 is 0. Now sender sends this message to the receiver. Okay. Sender sends this message to the receiver. Okay. So this message contains 4 bits. In addition to the message, it adds redundant or target bits to the receiver also. Now let's see what will happen at the receiver side. What will happen at the receiver side? At the receiver side also, it calculates parity bits. It calculates parity bits. So what is P1? 1357. 1357. What is P1 value here? 0. Let us assume that this message was delivered to the receiver. This bits. So what is P1? 1357. 1357. What is P1 value here? 0. Let us assume that this message was delivered to the receiver. This message was delivered to the receiver. So after it receives the message, it calculates the parity bit values. Okay. So how we can get P1? Already you know all the procedure. So P1 means what? 0110. 0110 means what? The number of ones are 0 only. So that means it adds 0 to the corresponding message. Next, let us check what is P2. So what is P2? 1011. 1001. So 1001 also contains even number of ones. So the result is 0. Next P3. So what is P3 value? What is P3 value? 0101. So in 0101 also we have even number of zeros. So here also we got the message as 00. If all the parity bits are 011. So 1001. So that means it adds 0 to the corresponding message. Next, let us check what is P2. So what is P2? 1011. 1001. So 1001 also contains even number of ones. So the result is 0. Next P3. So what is P3 value? What is P3 value? 0101. So in 0101 also we have even number of zeros. So here also we got the message as 00. If all the parity bits are 000, then receiver comes to know that there is no error in the message. So receiver accepts the message. Okay. Let us assume that this bit is modified. Instead of 1, let us assume that message was modified to 0. So instead of 1, so here actually what is the message? 1 is the message. Okay. So instead of 1, let the message is modified to 0. Now let us check how we get the error. Okay. If the parity bits, then we can get other than 0. Then we can get the parity bit values as 1. So now let us calculate the parity bits. So how we can get P1? 1357. So what is 1? 0. What is 3 position value? 0. What is 5 position value? 0. What is 7 position value? 1. Okay. So 0001. 0001. But the number of ones should be even only. So it adds 1 here. So P1 value is 1. So P1 value is 1. Okay. Now let us check P2. So how we get P2? 2367. So what is 2367? 10. What is 67? 01. 01. So number of ones are even only. So the parity bit is 0 only. Next, what is P3 value? 4567. What is 4567? 3001. 3001. 3001. So number of ones are odd. In order to make it as even, it adds 1 here. So now what is the parity result we got here? 101. So the receiver came to know that some of the bits are modified in the receiver, some of the bits are modified during the transmission. So there is an error. So in this way, at the receiver side, receiver detects the error. So now at which position that error was produced. So in order to know that, simply we have to find out the decimal number of 101. Okay. So here what is the position? P1, P2, P3. Okay. P1, P2, P3. What is P1 value? 1. What is P2 value? 0. What is P3 value? 1. So 101 in decimal notation is 421. Okay. What is the decimal value? 5. So that means at 5th position, that message was modified. Actually, at 5th position, what is the bit? 1. But that 1 is modified to 0. Now what the receiver will do? This receiver will modify that bit to 1. Okay. So in this way, at 5th position, what is the bit? 1. But that 1 is modified to 0. Now what the receiver will do? This receiver will modify that bit to 1. Okay. Now let us discuss about unrestricted simplex protocol. Unrestricted simplex protocol comes under elementary data link protocols. We have 3 elementary data link protocols such as unrestricted simplex protocol. Second one is simplex stop and wait protocol for noisy channel. Third one is simplex stop and wait protocol for noiseless channel, that is for error free channel. In this video we are going to discuss about the first data link protocol, the first elementary data link protocol, that is unrestricted simplex protocol. This protocol can also be called as utopian protocol. The dictionary meaning of the word utopian is ideal. So ideal means everything is perfect, nothing will go. This protocol can also be called as utopian protocol. The dictionary meaning of the word utopian is ideal. So ideal means everything is perfect, nothing will go wrong. So like Mr. Perfect. Okay. So we can say that unrestricted protocol is unrealistic protocol. Why? Because it is quite impossible to implement this protocol practically. So it is assumption only. So it is theoretical approach only. Practically it is impossible to implement this protocol. Why? Because here everything should be perfect. There will be no error, there will be no flow control, there should be infinite amount of data at both sender and receiver side. Everything should be ideal, but practically it is quite impossible. So now let's see why it is named as unrestricted simplex protocol. Unrestricted, the name itself specifies the meaning. There is no restriction on the sender side and receiver side. Sender can send any amount of data to the receiver at any time. So likewise, receiver can receive any amount of data from the sender at any time. So there is no restriction on the sender and the receiver. So that's why it is called as unrestricted. And simplex, we know the meaning of the word simplex. Simplex means the data can be transmitted only in one direction. So let me have host 1, host 2. So host 1 is nothing but sender mission or transmitter mission, whereas host 2 is nothing but receiver mission. Transmitter, receiver or sender, receiver. Okay. So here let us assume that host 1 wants to send some data to the host 2. So here the data can be transmitted only from host 1 to host 2. After receiving the data, host 2 cannot provide any acknowledgement to the sender, or host 2 cannot send any data to the host 1 or sender. Why? Because here the data can be transmitted in only one direction. So acknowledgement is not possible. Likewise, sending the data from this receiver to the sender is not possible. So that's why it is called as simplex protocol. Now let's see some points here. So acknowledgement is not possible. Likewise, sending the data from this receiver to the sender is not possible. So that's why it is called as simplex protocol. Now let's see some points. So acknowledgement is not possible. Likewise, sending the data from this receiver to the sender is not possible. So that's why it is called as simplex protocol. Now let's see some points. Here there are some assumptions in order to implement this protocol. So we need to follow some assumptions in order to implement this protocol. The first assumption is already we have seen this assumption. So this is unrealistic protocol. Why? Because it is quite impossible to implement this protocol. So we can say that it is unrealistic protocol. And the second one is sender. Sender means transmitter. So transmitter and the receiver. Transmitter and the receiver always ready. So transmitter mission, that is sender mission, that is host 1 mission, is always ready in order to send data to the receiver mission. So likewise, receiver mission is always ready in order to accept data from the sender. Okay, so they are always ready at any time. And the third constraint and the third assumption is sender has infinite amount of data. So sender is always ready with infinite amount of data. So at any time, sender can send infinite amount of data to the receiver. So likewise, receiver. So this is about sender. Next, fourth point is about receiver. Receiver has infinite buffer space. Receiver has infinite buffer space. So receiver can receives any amount of data sent by the sender. Here there is no errors. There is no errors. So there is no need of any error control. Here we are in the assumption that sender is sending some data to the receiver successfully. There are no errors during the transmission of the data. There is no corruption of any frames. So the frames data is not corrupted. So original frame will be received at the receiver. So there is no need to have any error control mechanisms. Frame control. The receiver has, this is about all amount of and ready in order to accept data from the sender. Okay, so they are always ready at any time. And the third constraint and the third assumption is sender has infinite amount of data. So sender is always ready with infinite amount of data. So at any time, sender can send infinite amount of data to the receiver. So likewise, receiver. So this is about sender. Next, fourth point is about receiver. Receiver has infinite buffer space. Receiver has infinite buffer space. So receiver can receives any amount of data sent by the sender. Here there is no errors. There is no errors. So there is no need of any error control. Here we are in the assumption that sender is sending some data to the receiver successfully. There are no errors during the transmission of the data. There is no corruption of any frames. So the frames data is not corrupted. So original frame will be received at the receiver. So there is no need to have any error control mechanisms. Why? Because sender is sending a frame to the receiver. We are assuming that that frame will receive correctly at the receiver. So all these are assumptions. Okay. And next one is no flow control. No flow control. Why? Because here what is the advantage of the receiver? At the receiver we have infinite buffer space. So let the sender sends the data at a very fast rate. Then there is no problem. Why? Because at the receiver we have infinite buffer. So receiver can receive the data. Receiver can receive the data in a proper manner because there is no problem here. At the receiver we have the buffer space as infinite. And next one is processing rate. Processing rate is neglected. Processing time is neglected. Processing time is neglected. After receiving the frame, receiver will take some time in order to process that time, in order to process that frame. So after receiving the frame from the sender, receiver needs to take some time in order to process that frame. But here there is no restriction on the time. So that's why we can simply neglect the processing time. At any time receiver can receive the frame. There is no problem. So we can reject that. Okay. And next one is missions always work properly. So that means missions won't crash. So here we have two missions, host 1 and host 2. So these two missions won't crash at any time. So these two missions will work properly. So these are the assumptions we need to follow in order to implement this protocol. Now let's see how the data will be transmitted from sender to the receiver. How the data will be transmitted from the sender to the receiver with the help of some diagrams. So at the sender we have, so this is sender mission. So this is sender mission. And this is receiver mission. Receiver mission. So here we have three layers. The first layer is network layer. So this is network layer. Second layer is data link layer. And the third layer is physical layer. So at the network layer, sender receives the data. So sender receives the packets. Get data from its previous layers. Okay. So sender receives packets at the network layer. Next, what the data link layer will do, we know that in data link layer, we represent the data in the form of the frames. So that those packets will be encapsulated into frames. So here the frames are prepared by the data link layer. So now the data link layer send these frames. Now the data link layer prepare the frames and it sends the corresponding frames to the physical layer or receiver of the receiver. Okay. So now here this is nothing but frame. So the frame is sending to the, here we have receiver mission. At the receiver also we have three layers. The first one is network layer. Second one is data link layer. Third one is physical layer. So the physical layer of the receiver mission simply receives the frame. It simply receives frames from physical layer of the sender mission. And the data link layer will simply extract the frames from the corresponding data. And the corresponding frames will be, delivered data. So what the data link layer will do? Data link layer will extract the frames from the corresponding data. And after that, the corresponding frames will be placed in packets. And those packets will be delivered to the network layer of the receiver mission. So in this way, the data will be transmitted from sender to receiver. So get data, send frame, received frame and delivered data. Okay, so this is about unrestricted simplex protocol. In the next videos we will see remaining two protocols. Now let us discuss about unrestricted simplex protocol. Unrestricted simplex protocol comes under elementary. Now let us discuss about simplex stop and wait protocol for noiseless channel, or this can also be called as simplex stop and wait protocol for error-free channel. So noiseless channel or error-free channel, both are same only. This concept comes under elementary data link protocols. We have three elementary data link protocols, such as, this is the first protocol. Next we have two more protocols, such as simplex stop and wait protocol for noisy channel, that is nothing but for error channel, and the third one is unrestricted simplex protocol. In this video we are going to discuss about this protocol. The name itself specifies the meaning. Simplex means the data will be transmitted in only one direction. So here let me have two missions, sender mission, receiver mission. So now sender can transmit data to the receiver, but receiver can't send any data to the sender. So that is about what is simplex. Simplex means the data can be transmitted from sender to the receiver in only one direction. And the next one is stop and wait protocol. So this is stop and wait protocol. So stop and wait means sender sends a frame and stops and wait for acknowledgement from the receiver. So after sender receives the acknowledgement, sender can send another frame to the receiver. So why it is named as stop and wait? Sender sends a frame and then stops and waits for acknowledgement from the receiver for the corresponding frame that is to be sent. After receiving the acknowledgement from the receiver, sender can send another frame to the receiver. But this is simplex protocol. Simplex protocol means data can be transmitted in only one direction. But here we have a flexibility that receiver mission can provide acknowledgement to the sender, even though it is simplex transmission. Simplex means data will be transmitted in only one direction. But here receiver has a flexibility. Receiver has a capability that it can provide acknowledgement to the sender. Okay? So that's why it is named as simplex stop and wait protocol for noiseless channel. So noiseless channel means there are no errors here. So that means here the communication channel means the transmission data, the transmission medium. Communication channel is error-free. Error-free. So error-free can also be called as noiseless. Communication channel is noiseless. That means if sender sends a frame, then that frame must be reached to the receiver successfully without any errors, without any noise. So that means that frame cannot be corrupted. It is not possible to make any changes on the frame. That frame won't be lost. So that is the meaning of the word noiseless channel or error-free channel. So in this protocol, the communication channel is error-free, so that if sender sends a frame to the receiver, then that frame will be successfully received by the receiver. So there are no errors in that frame. Okay, so that's why it is named as noiseless or error-free channel. But here the problem is it suffers with flow control. Flow control. We know what is a flow control. What is a flow control? Here the problem is receiver capacity is finite. So here receiver has finite buffer space. Receiver has finite buffer space, and the processing speed of the receiver, is also slow. So here flow control means let the sender sends data at a faster rate, whereas receiver consumes data at slower rate. So now here what is the problem? Here we have faster sender and slower receiver. So sender is sending data at a faster rate, whereas receiver is consuming the data. Receiver is processing the data in a slower rate. So now what will happen? Some of the packets, some of the frames that are sent by the sender will be lost. Why? Because sender is sending data at a very faster rate, whereas receiver is processing those frames at a slower rate. So some of the frames will be lost now. So this problem is called as flooding. So how we can solve this problem? Here we got this problem because of these characteristics. Receiver has finite buffer space. So here the size of the receiver is finite, very, very limited buffer that we have. And processing speed of the receiver is also very, very slower. So receiver consumes the data in a slower manner. So what will happen? Some of the frames arrived at the receiver may be lost because sender is sending so many frames at the faster rate. But at the receiver, the buffer space is very, very limited. So we can't store all those frames at the buffer. Okay, so that's why we got a problem called flooding. So how we can solve this problem? How we can solve flow control problem? In order to solve flow control problem, acknowledgements are introduced. So now what will happen? Sender is sending a frame to the receiver, and then sender stops and waits for the acknowledgement from the receiver for that frame. Suppose if the receiver successfully receives that frame, here there is no problem. Here we don't have any errors. So let the receiver successfully receive that frame. So after receiving the frame, receiver provides acknowledgement to the sender. So after observing that acknowledgement, sender can determines that frames or that frame was successfully arrived at the receiver. So sender can send another frame to the receiver. So here there is no loss of packets, no loss of any frames. Why? Because we have acknowledgements. Sender can send another frame to the receiver only after receiving the acknowledgement for the previous frames. So that is about how we can solve flow control, that is flooding problem, by providing the acknowledgements at the receiver side. Now let's see how the data will be transmitted from sender to the receiver. So here we have sender mission, here we have receiver mission. Here this is nothing but network layer, data link layer, physical layer. At the receiver also we have network layer, data link layer, physical layer. So first, sender gets data from its upper layers. So at the network layer we have packets. So sender gets packets from its upper layers. Okay, so at the network layer, sender gets the packets from its upper layers. So now what will happen is, we know that in data link layer, the corresponding data will be represented in the form of frames. So those packets will be converted into frames now. So now the task of the data link layer is the corresponding frames and transfers those frames to the network layer. At the network layer, the receiver mission will get the data in the form of packets. So once the receiver receives the packet, once the receiver receives the data, now it has to provide the acknowledgement for the corresponding frame. So that this is nothing but send frame. This send frame is nothing but acknowledgement. It is a dummy frame. It doesn't have any data. So this frame is nothing but acknowledgement. So here the physical layer at the receiver mission is providing acknowledgement to the physical layer at the sender mission. So now what will happen? At the physical layer at the sender mission is providing acknowledgement to the physical layer at the sender mission. So now this acknowledgement will be sent to the sender. So by observing that acknowledgement, sender can determine that frame has successfully reached to the receiver. So now sender can send another frame to the receiver. So very simple. First one, get data. Next, send frame. Receive frame. Deliver the data. Next, after that, it provides acknowledgement. So this is nothing but acknowledgement. Okay. Now the sender receives the acknowledgement. So after receiving the acknowledgement, same process will happen. Sender gets another packet, and that packet will be translated into frames. And data link layer sends the frames to the physical layer. Physical layer provides the frames to the physical layer at the receiver. Next, the corresponding data is delivered to the receiver. Okay. So this is about simplex stop and wait protocol for noiseless channel. In the next video, we will discuss about simplex stop and wait protocol for error-free channel. Now let us discuss about simplex stop and wait protocol for noisy channel. So noisy channel means error channel. This concept, this protocol comes under elementary data link protocols. First, let us see why it is named as simplex stop and wait protocol for noisy or error channel. Simplex means the data can be transmitted in only one direction, whereas stop and wait protocol means sender sends a frame to the receiver, and then sender stops and waits for the acknowledgement from the receiver. After receiving the acknowledgement only, sender can send another frame to the receiver. For noisy or error channel, but here the communication channel has errors. So there may be a possibility that we may get some errors. So communication channel has errors. Let the sender sends a frame to the receiver. So there may be a possibility that during transmission, that frame may be lost, or there may be a possibility that some of the bits of the frame are corrupted. That now let us discuss, and that packet will be translated into frames. And now let us discuss about simplex stop and wait protocol for noisy channel. So noisy channel means error channel. This concept, this protocol comes under elementary data link protocols. First, let us see why it is named as simplex stop and wait protocol for noisy or error channel. Simplex means the data can be transmitted in only one direction, whereas stop and wait protocol means sender sends a frame to the receiver, and then sender stops and waits for the acknowledgement from the receiver. After receiving the acknowledgement only, sender can send another frame to the receiver. For noisy or error channel, but here the communication channel has errors. So there may be a possibility that we may get some errors. So communication channel has errors. errors. Let the sender sends a frame to the receiver. So there may be a possibility that during transmission that frame may be lost, or there may be a possibility that some of the bits of the frame are corrupted. That means some of the bits of the frame are damaged. Let us assume that sender sends a frame to the receiver, but during transmission that frame is corrupted or damaged. Let that frame arrive successfully at the receiver. So now how receiver identifies that is the corrupted frame, that is the damaged frame. So for that we have error detection mechanisms. The most commonly used mechanism is checksum. So with the help of the checksum, receiver can identify whether it is the original frame or corrupted frame. Suppose if it is original frame, then the receiver accepts that frame. Suppose if it is corrupted frame, then the receiver discards that frame. So let's see how the data will be transmitted from the sender to receiver here. So here we have two missions. The first mission is sender, the second mission is receiver. So let sender sends a frame to the receiver. Let sender sends a frame to the receiver. Here every frame will have a timer. So sender will wait for the acknowledgement for the corresponding frame only for that particular time period only. If the time period expires, then the sender will retransmit the same frame once again. So here the sender sends a frame to the receiver, and then sender stops and waits for acknowledgement for the corresponding frame. So let us assume that that frame received successfully at the receiver. So receiver is providing some acknowledgement to the sender. Receiver is providing an acknowledgement to the sender. Let us assume that sender sends a frame to the receiver, but this is a damaged frame, corrupted frame. Some of the bits of the frame are damaged. Generally what will happen is at the receiver side, the receiver computes the checksum for error detection. Suppose if it identifies that it is a damaged frame, then the receiver simply discards the frame. Receiver simply discards the frame. But here we know that every frame will have a timer. So the sender will wait for that particular time period only. Let the timer period is 20 milliseconds. So sender will wait for only 20 milliseconds for the acknowledgement from the receiver. Let us assume that sender doesn't receive the acknowledgement. Here that frame has some errors. So what will happen now? The receiver may not send any acknowledgement to the sender. So in that occasion, after the time period expires, sender thinks that during transmission that frame is lost. So sender will retransmit the same frame once again. The same frame once again, and then receiver receives that frame and provides acknowledgement for the frame. Now let us assume that sender sends another frame to the receiver, another frame to the receiver. So let that frame receive successfully at the receiver side without any errors, without any damages. So what will happen now? Receiver provides acknowledgement to the sender, but assumes that that acknowledgement is lost. That acknowledgement is lost. So in that occasion, what will happen? We know that every frame will have a timer. So after the time period expires, sender will retransmit the same frame once again. Sender will retransmit the same frame once again. But is it original frame or duplicated frame? It is duplicated frame. Why? Because already here with this frame, there is no problem. There are no errors in this frame. This is original frame only, correct frame only. So already receiver has this frame. But sender doesn't receive the acknowledgement. So that's why sender retransmitted the same frame once again. So now the sender has two frames with the same data, So this is a problem. This frame is nothing but duplicated frame. This frame is nothing but duplicated frame. So how we are going to solve this problem? So sender has two frames, duplicated frames. In order to solve this problem, sequence numbers are introduced. Sequence numbers are introduced already. So now what will happen? Receivers. So in this way we can handle the noise or errors. So this is now let us discuss about stop and wait protocol. Here we have sender and receiver. Stop and wait protocol is very simple. Sender sends a frame to the receiver and waits for acknowledgement from the receiver. So receiver receives the frame and sends acknowledgement to the sender. So likewise, after receiving the acknowledgement from the receiver, sender sends another frame to the receiver. Receiver receives the frame and provides acknowledgement for the frame. So why it is called as stop and wait protocol? Sender sends a frame to the receiver and sender stops of sending another frame and waits for acknowledgement for the frame. After receiving the acknowledgement for the frame, then only sender can send another frame to the receiver. So this is about what is stop and wait protocol. There are mainly three problems which occurs in this protocol. So the problems are, the first problem is frame lost. Second problem is acknowledgement lost. Third problem is delayed acknowledgement. So these are the major three problems which occurs in this protocol. So first let us see the first problem. What is the first problem? Frame lost. So here we have sender as well as receiver. Sender sends a frame to the receiver, but let us assume that that frame is lost to the receiver, but the frame is lost. So every frame will have a timer. So timer means it is some time period. Let the time be. So this is called as stop and wait ARQ protocol. You will see this point later. Protocol. So what we are doing, we are adding a timer to this one. So this is called as stop and wait ARQ protocol. You will see this point later. So here sender sends a frame to the receiver. First problem by adding a timer to the stop and wait protocol. Corresponding acknowledgement from the receiver for that period only. If the time period expires, then what will happen? Sender will retransmit the same frame once again.
என்னடா பர்கர்ல தான் போச தரீங்க?
Now let us sender will retransmit the same frame once again. But here receiver thinks that it is the new frame. So receiver will provide acknowledgement for this frame. But here what is the problem? This frame is nothing but the oldest frame only. So this problem can also be called as duplicate frame problem. Seeing this frame 0. So receiver thinks that this is the duplicate acknowledgement from frame 0. Why? Because already receiver has frame 0. So it discards this frame and provides the acknowledgement. So this is the second problem. Acknowledgement, last problem, or this can also be called as duplicate frame delayed. That acknowledgement is taking too much of time to arrive at the sender. So that acknowledgement is delayed. We know that every frame will have a timer. So after the time period expires, sender will retransmit that frame once again. As well as what is the acknowledgement? Let this acknowledgement is acknowledgement 0. Okay. Now this acknowledgement is for this frame 0, ACK 0. So now sender receives ACK 0. So by observing that acknowledgement, receiver came to know that this is acknowledgement 0, but that acknowledgement is already received by the sender. So receiver simply discards this acknowledgement. Why? Because frame 0 is one more frame, that is frame 1. But now assumes that this acknowledgement is arrived at the sender now. So sender receives this acknowledgement. Now sender thinks that this is the acknowledgement for frame 1. But actually this acknowledgement is for frame 0. So this is the problem here. So after receiving the acknowledgement, sender thinks that this acknowledgement is for this frame 1. But this acknowledgement is for frame 0. So how to solve this problem? In order to solve this problem, while sending the acknowledgement also, receiver has to provide the sequence number. So let it be frame 0. So what is the acknowledgement? Let this acknowledgement is acknowledgement 0. Okay. Now this acknowledgement is for this frame 0, ACK 0. So now sender receives ACK 0. So by observing that acknowledgement, receiver came to know that this is acknowledgement 0, but that acknowledgement is already received by the sender. So receiver simply discards this acknowledgement. Why? Because frame 0 acknowledgement is already received by the sender successfully. So now what the sender will do? Sender will simply discard this acknowledgement. So sender will send a second frame. Likewise, the procedure will happen. Okay. So after some time, sender may receive acknowledgement for frame 1 like ACK 1. So likewise, it will receives. So here for the stop and wait protocol, what we are doing? We are adding timer as well as sequence number for the frame as well as sequence number for the acknowledgement. So this is called as stop and wait ARQ. Stop and wait automatic repeat request. So stop and wait automatic repeat request means it is a combination of stop and wait as well as timer sequence number for sequence number will be added to the frame as well as to the acknowledgement also. So this is about stop and wait protocol. Now let us discuss about why now let us discuss about sliding window protocol. It is mainly useful in order to overcome the problem with stop and wait protocol. The major problem with stop and wait protocol is at a time sender can send only one frame to the receiver. So after sending the frame to the receiver, sender has to wait until it gets an acknowledgement from the receiver. So after receiving the acknowledgement only, sender can send another frame to the receiver. So here the problem is in stop and wait protocol, the sender can send only one frame to the receiver at a time. Suppose if you want to send a lot of frames to the receiver, then sender has to wait for a lot of time. So that is the problem here. If sender needs to send a lot of frames, then it will take more amount of time. So we can overcome that problem with the help of the sliding window protocol. In sliding window protocol, sender can send multiple frames to the receiver without waiting for acknowledgement from the receiver. Let us see what is sliding window protocol. So here also we have sender as well as receiver. Let us assume that sender wants to send 10 frames to the receiver. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the sequence numbers of the frame. So sender wants to send 10 frames to the receiver. Here we have 10 frames from 0 to 9. So these are the sequence numbers of the frame. Here sender will maintain a window size. A window size. Let the size of the sender window size is 4. So here the window size is 4. So that means at a time sender can send 4 frames to the receiver without waiting for acknowledgement for the previous frames, for those 4 frames. Okay. So this is frame 0. Next this is frame 1. So frame 0, frame 1. Next to frame 2, frame 3. So sender is sending 4 frames to the receiver. Here we will have a window. Here the window contains 4 frames from 0 to 3. But for the receiver it will take some time in order to arrive at the receiver. Let us assume that after some time receiver receives frame number 0. So receiver successfully receives frame number 0. So after receiving frame number 0, it provides acknowledgement to the sender regarding frame number 0. So now here what is the size of the window size? 4. But sender successfully received frame number 0 acknowledgement. So now frame number 0 is empty. Why? Because already successfully received. Okay. So now what will happen? This window will move frames. So already sender sends these frames to the receiver. So these frames are, third one is selective repeat protocol. So we have three types of sliding window protocols, such as 1-bit sliding window protocol, go back and ARQ protocol, select to repeat ARQ protocol. So already 3 videos are uploaded on these 3 protocols. I will share the corresponding video links in the comments as well as description. So this is about now let us discuss about sliding window protocol. It is mainly useful in order to overcome the problem with stop and wait protocol. The major problem with stop and wait protocol is at a time sender can send only. Now let us discuss about 1-bit sliding window protocol. The name itself specifies the meaning 1-bit. That means the sender window size as well as the receiver window size is 1. That means at a time sender can send only 1 frame to the receiver and receiver can also receive only 1 frame from the sender. Let's see what is 1-bit sliding window protocol. So first sender can send 1 frame to the receiver and then sender will wait for the acknowledgement from the receiver. Only after receiving the acknowledgement from the receiver, then only it can send another frame to the receiver. So sender sends a frame to the receiver. After that, receiver provides acknowledgement to the sender. After receiving the acknowledgement, sender can send second frame to the receiver. So likewise, the process will continue. So we can say that 1-bit sliding window protocol is similar to stop and wait protocol. Why? Because in stop and wait protocol also, at a time, sender can send only 1 frame and receiver can receive only 1 frame. So sender sends a frame to the receiver, receiver receives the frame and provides acknowledgement to the sender, and after that sender can send another frame, then receiver receives the frame and provides the acknowledgement to the sender. So we can say that 1-bit sliding window protocol as well as stop and wait protocol, both are same only. Whereas if the window size is 2 bits, 3 bits, 4 bits, 5 bits, then both are different. So sliding window protocol and stop and wait both are different. But here 1-bit sliding window protocol as well as stop and wait both are same only. Okay. Let us discuss about 1-bit sliding window protocol with the help of these two figures, these two diagrams. Let us see the first diagram. Here we know that every frame is represented with the help of a sequence number. Here let us assume that sequence number size is 3 bits. Sequence number contains 3 bits. So totally we can store 2 power 3 frames now. Why? Because here the sequence number size is 3 bits. So totally we can store 2 power 3 sequence numbers. 2 power 3 means 8 sequence numbers. So totally we can store 8 frames from frame 0 to frame 7. If you observe here, this is frame 0, frame 1, this sequence number represents frame 2, this sequence number represents frame 3, likewise frame 4, frame 5, frame 6, frame 7. So every frame must have a sequence number. Okay. Here this is the first stage. So this is A. This column represents A. So this is sender state and this is receiver state. This column represents B. This is sender state and this is receiver state. So initially the sender has no frame to send. So that's why that is represented with the help of this vertical line. This vertical line specifies that sender has no frame to send to the receiver. Okay. Whereas if you see here, the vertical line is represented like this. So sender is waiting for first frame. Whereas here, sender is waiting for zeroth frame. Whereas if you observe the receiver, at a time receiver can receive 1 frame from the sender. So receiver is expecting frame number 0 from the sender. So that's why it is represented like this. So this portion represents frame 0. So receiver is expecting frame 0 from the sender. So this is A. Now let us see the big B state. Sender has sent frame 0 to the receiver. So that's why it is represented like this. This state represents frame 0. So sender transmits frame 0 to the receiver. But it will take some time for the receiver to receive that frame. So that's why here receiver is waiting frame number 0 from the sender. So receiver doesn't receive the frame number 0. It is still expecting frame 0 from the sender. So that's why here we have an arc like this. So this is frame 0. Now let us see the C state. So this represents C, this represents D. Okay. So sender sent frame number 0 and receiver receives frame number 0. So here the receiver receives frame number 0. So that's why it is waiting for frame number 1 from the sender. So that's why here we have an arc like this. This arc represents frame number 1. Receiver receives frame 0 and it is waiting for frame number 1 from the sender. Okay. Now let's see the next one. So now sender knows that frame is successfully submitted to the receiver. So it is waiting for the first frame. So still it doesn't receive the first frame. It is waiting for the first frame. Okay. Next here receiver is waiting for first frame from the sender. So what is the last diagram? Receiver is waiting for the first frame from the sender as well as sender is also waiting for the first frame. If it receives the first frame from the network layer, then that frame will be transmitted to the corresponding receiver. Okay, the frame will be transmitted to the corresponding receiver. So this is the first diagram. Now let us see the second diagram, how the data will be transmitted from source to the destination. So here A, B, we have two missions, A and B. A represents source, B represents destination. A sends, here if you observe this notation has three arguments. The first argument represents sequence number. Second argument represents acknowledgement number. Third argument represents packet number. So here A is sending frame number 0. So 0 is nothing but frame 0 sequence number. So this 1 is nothing but acknowledgement. Let us assume that previously A has received frame number 1 acknowledgement from the receiver. Okay. So this 1 represents acknowledgement number. Assumes that previously host A has received frame number 1 acknowledgement from the receiver. So that's why here we have 1, comma. What is the next one? Packet number. Packet number is nothing but combination of host as well as sequence number. Here the host is A sequence number is 0. So A0. So sender sends this frame to the receiver. So now host B gets 0, 1, A0. So host B gets 0, 1, A0. Okay. Next here B has received the frame from the receiver. So now it has to provide acknowledgement to the sender. So that's why it is sending one more frame. So B sends, here we have in addition to the acknowledgement, here 0. So 0 is nothing but frame 0 sequence number. So this 1 is nothing but acknowledgement. Let us assume that previously A has received frame number 1 acknowledgement from the receiver. Okay. So this 1 represents acknowledgement number. Assumes that previously host A has received frame number 1 acknowledgement from the receiver. So that's why here we have 1, comma. What is the next one? Packet number. Packet number is nothing but combination of host as well as sequence number. Here the host is A sequence number is 0. So A0. So sender sends this frame to the receiver. So now host B gets 0, 1, A0. So host B gets 0, 1, A0. Okay. Next here B has received the frame from the receiver. So now it has to provide acknowledgement to the sender. So that's why it is sending one more frame. So B sends, here we have in addition to the acknowledgement, here we can also send the sequence number also. Here what is the notation? Sequence number, acknowledgement, packet. In addition to the acknowledgement, it can also send its own packet, its own frame. So B sends, so it is sending its own frame. Host B is sending its own frame. That frame sequence number is 0. And what is the 0? The 0 is nothing but acknowledgement to the sender. Previously A has sent sequence number 0. So the second 0 specifies that it is the acknowledgement for the source. Okay, comma. And this is the packet number. We know that packet is represented with the help of host as well as sequence number. Here the host is B as well as sequence number is 0. B sends, and what is the 0? The 0 is nothing but we can also send the sequence number also. Here what is the notation? Sequence number, acknowledgement, packet. In addition to the acknowledgement, it can also send its own packet, its own frame. So B sends, so it is sending its own frame. Host B is sending its own frame. The frame sequence number is 0. And what is the 0? The 0 is nothing but acknowledgement to the sender. Previously A has sent sequence number 0. So the second 0 specifies that it is the acknowledgement for the source. Okay, comma. And this is the packet number. We know that packet is represented with the help of host as well as sequence number. Here the host is B as well as sequence number is 0. B sends 0, B0. So now A receives that message. A gets 0, B0. So by observing this acknowledgement number, here the second argument is acknowledgement number. So A comes to know that sequence number 0, that is frame number 0, is correctly arrived to the sender, correctly arrived to the receiver. Now A can send first frame to the receiver. So previously A has sent 0th frame number 0. Now A can send first frame to the receiver. So A sends, so this 1 represents frame number 1 sequence number, comma, previously A received acknowledgement for frame number 0 sequence number. Previously A received frame number 0 acknowledgement. So this 0 represents that acknowledgement number, comma, packet number A, and what is the sequence number? A1. So A sends this message to the receiver. So let's see this diagram. So here B sends, here A sends 1, A sends 1, 0, A0. Okay, A sends 1, 0, A0. So 1 means frame number 1 sequence number. The 0 means previous frame acknowledgement number as well as A1. Now B gets 1, 0, A0. B gets 1, 0, A0. Now B has to send acknowledgement for the first frame. So B sends, so this 1 specifies that B is sending its own frame. The frame sequence number is 1. In addition to the sequence number, B can also provide acknowledgement for the previous frame. So what is the previous frame? 1. What is the previous frame sequence number? 1. So that 1 is provided here. This is nothing but acknowledgement. Next, packet number. So B is the host, 1 is the sequence number, B1. Now A gets 1, B1. So likewise the transmission will be happening from sender to receiver. So this is about 1-bit sliding window protocol. Now let us discuss about go back N ARQ protocol. ARQ stands for automatic repeat. This Q stands for request. N, this N specifies that sender window size is N, whereas receiver window size is 1. So here what is the sender window size? N. So at a time sender can send N frames to the receiver. Here we can say that go back N ARQ protocol uses a concept called pipelining. Pipelining means sending multiple frames from sender to receiver without waiting acknowledgement for previously sent frames. Now let us see the go back N ARQ protocol. Here we have step 1, step 2, step 3, step 4, step 5, step 6. Let us see step 1. Sender wants to send 7 frames to the receiver from 0th frame to 6th frame. Let us assume that sender window size is 4. So at a time sender can send 4 frames to the receiver. So here the sender window size is 4. So sender is sending 4 frames to the receiver. So this is window. So window contains 4 frames from 0 to 3. This is sender, this is receiver. So sender is sending 4 frames to the receiver. So 0, 1, 2, 3, 4 frames to the receiver. But it will take some time for the receiver in order to receive those frames. After some time, letter 0, receiver is providing acknowledgement to the sender. So this is nothing but frame number 0. So here there is no change in the window size. So window size contains 4 frames from 0 to 3. Now let's see step 3. Upon receiving acknowledgement from the receiver, sender can send another frame to the receiver. Why? Because here the window size is 4, but the acknowledgement for the 0th frame is already received. So one frame is free. So that's why sender is sending 4th frame to the receiver. Now this window size is moved by 1 position. Why? Because acknowledgement is received for 0th frame. So that's why this window is slided by 1 position. So now the window is from 1st frame to the 4th frame. So window size is 4 only. After some time, let us assume that receiver receives frame number 1. Upon receiving frame number 1, receiver provides acknowledgement to the sender. So upon receiving frame number 1, so what the receiver is doing? Receiver is providing acknowledgement to the sender. So this one is nothing but this acknowledgement line. So after sender receives the acknowledgement, now we can sender can receiver receives frame number 0. Receiver receives frame number 0. So 0, 1, 2, 3, 4 frames to the receiver. But it will take some time for the receiver in order to receive those frames. After some time, let us assume that receiver receives frame number 0. Receiver receives frame number 0. So upon receiving frame number 0, receiver is providing acknowledgement to the sender. So this is nothing but frame number 0. So here there is no change in the window size. So window size contains 4 frames from 0 to 3. Now let's see step 3. Upon receiving acknowledgement from the receiver, sender can send another frame to the receiver. Why? Because here the window size is 4, but the acknowledgement for the 0th frame is already received. So one frame is free. So that's why sender is sending 4th frame to the receiver. Now this window size is moved by 1 position. Why? Because acknowledgement is received for 0th frame. So that's why this window is slided by 1 position. So now the window is from 1st frame to the 4th frame. So window size is 4 only. After some time, let us assume that receiver receives frame number 1. Upon receiving frame number 1, receiver provides acknowledgement to the sender. So upon receiving frame number 1, so what the receiver is doing? Receiver is providing acknowledgement to the sender. So this one is nothing but this acknowledgement line. So after sender receives the acknowledgement, now we can say that one position is free. Why? Because it received acknowledgement for the first frame. So now the sender can send the next frame. So the next frame is 5th frame. So now the sender is sending 5th frame to the receiver. So now this window is slided. This window is moves by 1 position. Moves by 1 position. So previously the window is from 1 to 4, whereas now the window is from 2 to 5. Okay, 2 to 5. This is step 4. Now let us see step number 5. But let us assume that acknowledgement for the frame number 2 is lost. Assumes that acknowledgement for the receiver. Let us assume that receiver receives frame number 2. So upon receiving the frame number 2, it provides the acknowledgement to the sender, but assumes that acknowledgement is lost. That acknowledgement is lost. Here what will happen is every frame we have a timer. Sender will wait for the acknowledgement from the receiver for that particular time period only. Let the time period is 10 milliseconds. So it waits for the acknowledgement for 10 milliseconds only. If the time period expires, then what the sender will do is sender will retransmit automatic repeat request. So that means automatically sender will go back to N. So here it doesn't receive acknowledgement for frame number 2. So it will goes to this frame number 2 and it will retransmit the corresponding 4 frames one more time. So already frame number 4 is sent, frame number 5 is sent, frame number 4 and 5, 3rd frame, 4th frame, 5th frame are already sent. But what the sender will do? Sender doesn't receive any acknowledgement for the 2nd frame. So after the time period expires, what the sender will do? Sender will go to, it doesn't receive acknowledgement for 2nd frame. So sender go back to. So it will goes to 2 and it will retransmit the frames one more time. It will retransmit the frame one more time. So now the window is from 2 to 5. So this is about what? Go back and automatic ARQ. ARQ stands now let us discuss about selective repeat protocol. It is mainly useful in order to overcome the problem with go back NARQ protocol. The problem with go back NARQ protocol is if a frame is lost, then all the frames which are in the window are retransmitted once again. Whereas if you take selective repeat protocol, if a frame is lost, then only that lost frame will be selected and it will be repeated. That means it will be retransmitted one more. Likewise, if the sender window size is 4, then the receiver window size is also 4. Okay. Let us discuss about selective repeat protocol with the help of these steps. So step 1, step 2, step 3, step 4, step 5, step 6. Let us see step 1. Here sender wants to send 7 frames to the receiver from 0 to the 6th frame. Here let us assume that window size of the sender is 4. So the receiver window size is also 4. So first the sender is sending 4 frames to the receiver from 0 to the 3. So now 0 to 3 is nothing but the current window now. Okay. But it will take some time for the receiver in order to receive those frames. Here the receiver window size is also 4. Okay. If you want, we can draw the same diagram here also. Okay. So this is step 1. So what is step 1? Sender is sending 4 frames to the receiver. Now let us see step 2. Let us assume that after some time receiver receives frame 0. So once it receives frame 0, then it provides acknowledgement 0 to the sender. So receiver receives frame number 0. So once it receives, it providing acknowledgement 0 to the sender. Okay. So the window size is from 0 to 3 only. Now now for the frame number 0, the acknowledgement is received. So we can say that now we can advance the window, we can move the window by one position. Why? Because here the size of the window is 4, but for the 0th frame, the acknowledgement is received. So now we can store one more frame here. So that's why here sender is sending the next frame to the receiver. So what is the next frame? After 3 we have 4. So sender is sending frame number 4 to the receiver. So now the window is from 1 to 4. So what is the size of the window? 4. Okay. After some time, let us assume that receiver receives frame number 1. So after it receives frame number 1, it can provide that frame acknowledgement to the sender. So this one represents receiver is providing acknowledgement 1 to the sender. Acknowledgement 1 to the sender. So here the window is same only from 2 to 5. If we want at the receiver also, we can draw the same window. Okay. Now let us see the next step. Now let us assume that frame number 2 is lost. Let us assume that this frame number 2 is lost. Here what will happen is every frame will have a timer. Sender will wait for the acknowledgement from the receiver for that particular time only. If the time period expires, then the sender will retransmit that frame once again. So here within the particular time, sender doesn't receive any acknowledgement from the receiver. So what will happen? Sender will retransmit that frame one more time. So here sender doesn't receive acknowledgement for frame number 2. So that's why sender will retransmit that frame one more time. Whereas in go back and protocol, what will happen? The sender will retransmit all the frames which are in the current window one more time, even though those frames are already sent. So here in the window we have 2, 3, 4, 5. So already third frame is sent, fourth frame is sent, fifth frame is sent. But in go back ARQ, what will happen? The sender will retransmit all the subsequent frames which are after that frame one more time. So 2, 3, 4, 5 frames will be retransmitted one more time. Whereas in selective repeat protocol, what will happen? Only that last frame will be selected and it will be repeated. That means it will be retransmitted once again. So here the last frame is second frame. So sender will retransmit second frame one more time. Or here there may be a possibility that sender receives second frame successfully. Receiver receives second frame successfully, but it identifies some errors in the second frame. So once it identifies errors, then the receiver will simply send negative acknowledgement. NACK2. So receiver is sending negative acknowledgement for the second frame to the receiver, to the sender. So receiver is sending negative acknowledgement for the second frame to the sender. So once the sender sees that negative acknowledgement for the second frame, then it comes to know that there are some errors in the second frame. So it will retransmit that error frame one more time. Here the error frame is second frame. So that second frame will be retransmitted one more time. So this is the major advantage of the selective repeat protocol. Only that last frame or the frame which has the errors will be retransmitted. Whereas coming to the go back n protocol, what will happen? All the frames which are in the window will be retransmitted one more time. So here after the second frame, sender sent 3 frames, such as third frame, fourth frame, and fifth frame. But those 3 frames will also be retransmitted one more time. So here we have in 2 situations we may get the error. So what is the first situation? Let us assume that the packet was lost. The receiver doesn't receive packet 2 during the transmission. Second frame is lost. So this is the first scenario. Next to second scenario, receiver receives the frame successfully, but it identifies that there are some errors. So once it identifies the error, it sends negative acknowledgement to the sender. So NACK2 to the sender. So once the sender receives that negative acknowledgement, simply retransmits that last frame, that is second frame, one more time. So this is about selective repeat protocol.
students? Many organizations have multiple LANs and wish to connect them. LANs can be connected by devices called bridges. These bridges operates in the data link layer. Before getting into the technology of bridges, it is necessary to take a look at some common situations in which bridges are used. We will see the reasons why the single organization may end up with multiple LAN systems. The first reason is many universities and corporate departments have their own LANs, primarily to connect their own personal computers, workstations, and servers. Since the goals of the various departments differs, different departments use different LAN systems. And this is without regard to what other departments are doing. There is a need for interaction, so bridges are needed. In this example, multiple LANs comes into existence due to autonomy of their owners. The second reason is the organization may be geographically spread
In today's lecture, we will see IEEE 802.1d spanning tree protocol. We will start the session with the outcomes. In today's session, we have 4 outcomes. Let's see what are they. Upon the completion of the session, the learner will be able to. Outcome number 1, we will understand the need for redundancy and how failure is handled. Outcome number 2, we will know about broadcast storm. Outcome number 3, we will understand the spanning tree protocol. And the last outcome, we will understand various key concepts and the terms in spanning tree protocol. Let's start with the redundancy concept. Redundancy is always good because it enables the users to access network resources despite path disruption. Suppose if there is only one path between the sender and the receiver or between two nodes, then if that path fails, then obviously the sender will not be able to reach the receiver. And what's the main advantage of this redundancy? It improves reliability and it improves availability. In technology, 2 is 1 and 1 is none because a single connection means it is a single point of failure. And if that single point encounters failures, and everything will become down. So creating redundant links is very simple and is always advisable because if we encounter some failures, we will be able to handle the situation perfectly. Let's see a scenario with redundancy. In this scenario, we have many ways to reach the internet. Suppose if this guy, that is PC1, wants to reach internet, so it has this way to reach the internet. Similarly, it can take this way, and this way. Or it can take this way, and this way. We have multiple paths for PC1 to reach the internet. In case if this path fails and PC1 has another way to reach the internet, that is this way, this, and this. So redundancy is always good. But in a switching world, redundancy causes some serious drawbacks. Let's see what is that. In this case, there is no redundancy. Suppose if any device is connected to this port, if it wants to contact a device which is connected to this port, so this device will be sending the data to this port, and this switch will take the data to this port, and this switch will then forward the data to the destination. In case if this link fails, and obviously the sender will not be able to reach the receiver. And that is why we are introducing a redundant link like this. And this is what a redundant link is. Suppose if this link fails, this switch can forward the data to this switch, and this switch in turn will forward the data to this switch so that failures are handled. But this introduces a very serious drawback. Let's see what is that. Let's assume there is a device that is connected to this port. And if this device is sending a broadcast, obviously all the ports will be receiving this broadcast. So this switch will be forwarding this broadcast message on all the outgoing links except this port because this is the incoming port. Obviously this broadcast will be sent to this switch through this port and to this switch through this port. And let's name this broadcast message as B. So this message B will be sent on this port as well as this port. So this switch will be receiving through this port and this switch will be receiving through this port. And this switch is receiving a broadcast in this port and its job is to forward this on all outgoing links. So what it will do, it will be forwarding this broadcast message B on all the outgoing links. So obviously this switch will also be receiving this copy of this broadcast. Now remember, already it has received a broadcast through this port. Now this switch is giving the same broadcast message through this port. So what it will do, it will send this broadcast through this link and this switch is receiving this broadcast in this port and this switch wants to broadcast this to all the outgoing ports except this port because this is the incoming port from this switch. So this switch will be forwarding this broadcast on all the outgoing ports including this port because this is the outgoing port. Obviously this switch will also be receiving the same broadcast through this port. When it receives the broadcast message through this port, what it has to do? It has to send that on all the outgoing links. So this switch will be forwarding this. And what about this broadcast message? This switch already received one broadcast message through this switch. And what about the first broadcast message that was sent by the switch? So this has received the broadcast in this port and it will be sending the broadcast message through this port to the switch. And again this switch is receiving a broadcast through this port. So what it has to do? It has to forward this on all outgoing ports. So at one fine point of time, the entire network will be full of broadcast messages. So this takes the whole network down. Because of this broadcast, the whole network will be down at some point of time. Because the entire network will be flooded with broadcast messages only. So the network will be down after some point of time. And that is what we call as the broadcast storm. Because of this redundant link, there is a loop. And because of this loop, there is a broadcast storm. We need to handle the situation. Though LAN redundancy is good, we need to handle this. Let's see it with an animation. Say this is the PC which is sending a broadcast message. So the switch is now broadcasting to all the ports except this port. And this broadcast is forwarded to all the ports. At one fine point of time, this broadcast is creating a storm in the network. And ultimately, it is going to take the entire network down. Because of this single broadcast message, and there is a loop. That is, this is the actual loop. You see, this is the actual loop. So this single broadcast is ultimately taking this single broadcast message and there is a loop. That is, this is the actual loop. You see, this is the actual loop. So this single broadcast is ultimately taking down the entire network, which we call as the broadcast storm. Then how this is handled? So spanning tree protocol handles the situation very perfectly. Let's see how spanning tree protocol handles the situation. So PC1 is sending a broadcast. This switch is broadcasting this to all the outgoing ports. Though we have a redundant link here, it is temporarily blocked. And this switch is also broadcasting the same information. And obviously this switch is going to broadcast, but see the same message when it is received back to S1, it is dropped. Because this link is a temporary link. This link is a backup link. This backup link will be used only when the existing link goes down. So this is how spanning tree protocols handles the situation. So we need redundancy and we don't want this redundancy to cause some problems. And that is why we are going for spanning tree protocol where we have redundant links, but these redundant links will be used only when it is needed, or to be precise, these redundant links will be made available only when the switch or the existing links encounter some failures. Let's see the key facts of spanning tree protocol. The key facts of spanning tree protocol include the original spanning tree protocol, that is 802.1d, was created to prevent loops. How it can prevent loops? Switches send probes into the network to discover loops. So what the switches will do periodically, it will VLAN stands for Virtual Local Area Network. A VLAN is a local area network where the computers, servers, and other network devices are logically connected regardless of their physical location. So even if these devices are scattered in different places, it wouldn't matter, because a VLAN can logically group them into separate virtual networks. And the purpose of a VLAN is for improved security, traffic management, and to make a network simpler. So as an example, let's say you have a 3-story office building, and in this building you have computers that belong to certain departments that are mixed in with computers that belong to other departments on the same floor. So the red computers represents the accounting department, the blue computers represent the shipping department, and the green computers represent the support department. Now as you can see, all these computers from these different departments are all connected to a switch. So they are all on one segment on a local area network, or LAN. So all the network broadcast traffic are mixed in with other departments. So the departments are all seeing each other's network traffic. Now suppose, as a network administrator, you wanted to separate the network broadcast traffic from these departments from each other, so that the accounting department doesn't see any traffic from support, support doesn't see any traffic from shipping, and so on. Now one way to solve this is to physically move the computers that belong to the same department and put them together, such as putting them on the same floor and deploying extra network hardware and cabling. But that could be a hassle and unnecessary work. But there is an easier way to accomplish this, and that is by creating VLANs. By using VLANs on a VLAN-capable switch, you can logically create several virtual networks to separate network broadcast traffic. So in this case, we're going to create 3 VLANs for the 3 different departments. So we're going to create a VLAN for the accounting department, and then we'll create another VLAN for the support department, and then we'll create one for the shipping department. So now, as the VLANs are implemented, the traffic between the 3 departments are isolated, so they won't see any traffic created from the other departments. They will only see their own network traffic, even though all the computers from the different departments share the same cabling and switch. So in our example, the VLANs were own network traffic, even though all the computers from the different departments share the same
Now let us discuss about collision-free protocols. The name itself specifies the meaning. These protocols are mainly useful in order to free the collision so that we won't have any collision. Mainly we have two collision-free protocols. The first one is bitmap protocol. Second one is binary countdown protocol. So first